TechTown Detroit here in Detroit, Mr. Paul Reiser Jr. for some opening comments. Paul?
Thank you, Mark, and welcome each and every one of you for tuning in today to today's Erie Hack 3.0 semifinals hosted by TechTown Detroit and Wayne State University. I have to start by definitely acknowledging that this unique event would not be possible without our new and returning Erie Hack organizing and lead partners in the cities of Windsor, Cleveland, Toledo, and Buffalo, and of course, Detroit as well. Thank you to Cleveland Water Alliance, We Tech Alliance in Windsor, Mid-Story in Toledo, University at Buffalo Blackstone Launchpad, and of course, TechTown Detroit here in Detroit, Michigan. We know that collaboration is key and we are stronger when we work together to solve our Great Lakes' greatest challenges. And that's what Erie Hack is all about. We're also grateful for our Erie Hack funders and our champions. So this year's event is presented by First Solar Community Giving Fund of the Greater Toledo Community Foundation, Northeast Ohio Regional Sewer District, and supported by OHM Advisors, Connecticut, Case Western University, Leonard Gelfand STEM Center, the Community Foundation for Greater Buffalo, Cleveland Metro Parks, and the Fred A. and Barbara M. Erb Family Foundation. Thank you all for your continued and truly, truly valuable support. In 2017, Erie Hack issued a challenge to innovate the lake. Forward thinkers from across the Lake Erie Basin answered this call, creating technologies and ideas with the potential to drive Lake Erie's ecology and economy into the 21st century. Now, this year in 2021, we are so excited to have reached the semifinal round of this third iteration of Erie Hack. This year's competition activated and accelerated some of the best and brightest entrepreneurs, students, retirees, committed citizens, and creative thinkers from across the Lake Erie Basin communities to work for our most precious natural resource. And so at this time, when the fun starts, it's my pleasure to introduce to you your MC for today's event, Mark S. Lee. Mark is the president and CEO of the Lee Group, a media contributor across the state of Michigan and beyond, and an award-winning radio host here in Detroit, Michigan. Mark, take it away.
All right, so thank you. Have known Paul for quite a while. He's an outstanding individual, great leader. We appreciate all of your contributions. And thank you, everyone. I'm very happy to be here. I'm pleased to be your MC for the afternoon for this exciting event. And it's going to be a wonderful afternoon of activities in terms of presentations. And it's an honor for me to be here with all of you today. And I'm very fortunate to, like I said, be your MC. We're after several months of many meetups, hacking days and pitches across the region, 12 Erie Hack semifinalists teams remain. 12, only 12 remain. That's right, this is very exciting. These teams represent Detroit, Cleveland, Buffalo, and Toledo, all legendary cities, all cities that we have something in common with. 12 teams with truly innovative solutions for our Great Lakes' biggest challenges around issues like surface water quality, infrastructure, and community water resources. After today, the best of these innovations will move forward to the Erie Hack Finals, hosted by Cleveland Water Alliance on November 18th. And get this, they will be competing for $45,000 in funding and support services. I will repeat that. They're going to be competing on November 18th for $45,000 in funding and support services, and we know that is sorely needed, no question about that. Before we get started, though, let's take a minute and now to meet the folks who will choose amongst these winning teams. Our esteemed list of a judging panel, I should say. And judges, at this time, we ask that you please turn on your cameras to be acknowledged as I call your names. All right, representing the great city of Toledo, Dr. W. Robert Midden, Research Professor in Chemistry Department at Bowling Green State University.
Howdy. Glad to be here.
Thank you. So glad to have you. Representing across the border, the great city of Windsor, Ontario, Mr. Eric Kuzmierczyk, Member of Parliament for Windsor-Tecumseh. Representing the Motor City, Detroit, Valencia Mobley, PE, Deputy Director and Chief Engineer of the Detroit Water and Sewage Department.
Hello, glad to be here.
So glad to have you. Thanks for joining us. Representing the great city of Buffalo, Bobby Thoman, Senior Sustainability Manager of NOCO, N-O-C-O, Energy Corporation. Bobby.
Thanks for having me.
So glad to have you. Thank you for joining us. Representing the great city of Cleveland, Mr. Michael Chum, Vice President of Product Development at Moen.
Everybody.
Michael. Hi, good to see you again. All right. So we have this esteemed panel of judges who will be helping us and certainly judging today's activities. And we will certainly be picking those who will be moving forward to the next round for November the 18th. And you know what? This is exciting. This is exciting that we're all coming together to hear these pitches. And before we move into the pitches, I just want to take one more moment to thank all of our judges, partners, and sponsors. These folks are really leading the pack across the board when it comes to this kind of work, and they are generously donating their time to be a part of Erie Hack, which wouldn't be possible without each and every one of you. So those of you tuning in, we thank you for also participating. And now, so while we're here, without further ado, let's start the pitches. Each team will have 5 minutes to pitch their project, followed by 5 minutes of Q&A from the judges. The teams will pitch in 3 blocks with 10-minute breaks in between for our judges to update their score sheets. Now let's meet our very first team, the Island Hoppers. Now come on, this is exciting. I know I can't see you. I want you to give them a round of applause wherever you might be sitting. But let's meet our first team, the Island Hoppers. Island Hoppers, whenever you're ready, please turn on your cameras and mics, share your screen, and begin your pitch. As soon as you start, Felicia will go ahead and start her timer, which is set for 5 minutes. Good luck.
Thank you. Felicia, I'm seeing a sign that says host disabled, participant screen sharing. Not anymore. Is my audio on? Can you hear me?
Yes, we can hear you just fine.
Okay. I'm going to start. My name is Mike Minnick, as previously mentioned. Thank you very much. I'm representing Island Hoppers and the attempt to get a green ribbon up the river. The jumping off point for our hack is community water resources and bringing surface water quality. Here's a picture of the Dorothy Ann Pathfinder. It's a 700-foot long, 70-foot wide freighter that carries 27,000 tons of material. It's a skyscraper on its side. The forces required to move this ship up the river are immense, and those forces bounce around in the dredged out river channel. It's difficult for life in the sheet pile line sections of the river to thrive. In fact, 9 of the 14 rivers feeding Lake Erie are areas of concern by the EPA, specifically for loss of fish habitat and degradation of fish and wildlife populations. Significant issues considering that Lake Erie has the most abundant fish populations of all the Great Lakes. It is a challenge for fish to move from the mouth of the river to the headlands. That's why we need a green ribbon running through it. Enter the green bulkhead. There's two ways that bulkheads can be greened up. The river dictates what happens.
Hey, Mike, I'm gonna just stop you there real quick. Would you mind putting your pitch into presentation mode? That the slides can advance because they haven't been advancing.
Oh, I'm sorry. It is on my end. Let me.
Oh, interesting. Okay. That was,
see that, though.
yeah. So I think he was advancing the slides, but we couldn't see them advancing. Would you like to begin again and try again? I'm so sorry.
That's all right. So help me out here. You are seeing my screen, non-presentation mode. Is that true?
Yeah. So you
Okay.
weren't on presentation mode. We're just having some technical difficulties here. I can restart the timer if you want to start from the beginning since we weren't able to see the slides as they were running.
If that works for you. Can you see a freighter in a river right now?
Yeah, yeah,
Okay, and now I'm gonna put it in presentation mode
yeah.
and it's good. And if I advance it, it advances.
Are you on presentation mode?
I am. And
Okay.
I'm flipping the slides.
Okay. Yeah, okay. Try going on the slideshow tab.
Okay.
On the top, that says home, insert, design, transitions, animations, and then
Okay.
click on slideshow.
Right.
Okay, and then click from beginning.
Mhm.
It might be the screen share.
Okay,
Maybe he's
yeah.
sharing the
There's-
PowerPoint window and it's
I see
not.
what's happening. Okay, there's something off. Okay, so if you don't mind staying on this screen then and starting from the beginning and not being on presentation mode, so that way we can see your slides because we didn't see them as they were progressing.
Okay, do you see them progressing right now?
No.
Okay, can I just go, can you see them now?
Yes, yeah, you
Okay.
should just stick on this mode. Okay, thanks.
It's a presentation mode issue, so I'll just go off this.
No worries, yeah, all good.
Okay.
Thank you.
All right, shall we start over again? Is that the best
Yeah.
thing? All right, let's do it.
Let me just reset my timer and then, okay, I'm ready when you are.
Okay. So, thank you, everybody. Again, I'm Mike Minnick with Island Hoppers. We're looking to get a green ribbon up the river. That's our proposal for Erie Hack 2021. Our jumping off point for the hack is community water resources and surface water quality. Here's a picture of the Dorothy Ann Pathfinder. The Dorothy Ann Pathfinder is a 700-foot long, 70-foot wide, 27,000-ton freighter that goes up and down all the rivers of the Great Lakes. The forces that are required to move this ship are immense, and they bounce around in the sheet pile line channels, making it difficult for life along the pile to really thrive. In fact, like I said, 9 of the 14 rivers feeding Lake Erie are areas of concern by the EPA, specifically for loss of fish habitat, degradation of fish and wildlife populations. Now, that's a significant issue considering that Lake Erie has the most abundant fish population of the Great Lakes. It's a challenge for the fish to move from the mouth of the river to the headwaters for breeding, and that's why we need to get a green ribbon running through the river. Enter the green bulkhead. 2 ways to green the bulkhead, the land side and the water side. Now, for example, the Cleveland Metro Parks has had success cutting back the bulkhead and creating pools behind it, but land is not always available for that option, and then the water side must be used. While the substantial task of getting all the stakeholders together and getting those attempts into the river was successful, there's yet to be a successful commercial product that matches what the river has to throw at it. They were either washed out, they were crushed, torn up, or sunk. So how can an island be made to handle such harsh conditions of the river? 9,000 gallons flowing per minute, ice flows, ship crush potential, the thrusters. It has to be cost effective and it has to be scalable. Enter our idea, the basket. The basket is made out of fire hose, recycled fire hose at that. It's woven and bolted together. It's filled with closed cell backer rod to give it buoyancy. And this system then makes it completely adjustable in its size, in its weave, in the matrix to put into the center, and its buoyancy. It differs from the previous attempts in two ways. It has a very low center of gravity, so it will ride in the water, not on top of the water, with buoyancy around its perimeter. It'll act like a boat, and it will not be crushed. Everything in it is flexible, so if it is crushed, it'll come back. Very versatile, very valuable design. But how valuable is it? One basket, 24 inches by 18 wide, the size of the tires hanging off the walls today, will yield about 100 cubic feet of habitat. Since value is often monetized, that would be around $1.70 per cubic foot. Not bad for waterfront property. But we think we could do better. In implementing this, we could work with the EPA and the Department of Wild Natural Resources and get it in place over time. But in true hack fashion, there's a better way to do it. We could be faster and more cost effective, and we can make this more of a community involvement. We could do that by lacing the river with the help of high school STEM programs. Remember, there's no tooling required, no special things necessary to build these baskets, and they're the size of totes, so they can be started anywhere. Summer camps at zoos and science centers are good targets. Team building activities on the corporate level, civic interest. As an example, Westlake, the city of Westlake in Ohio, has 4x8 planters along one of their main roads. And there's 220 of them. And there's a waiting list every year to get to plant one of those planters. And some of them have been in a family for 3 generations. And we could always play the advertising card to get additional funding. But the need is validated by past attempts, and the teamwork by the stakeholders is in place to make it happen. The baskets would be very visible, making an impact on the communities. They begin to clear the river AOC impairments. The design draws on existing efforts to work where others have not, and no capital requirement. It's recycled materials with minimal upkeep. Very quick to implement. How quick? We could have 3 to 5 baskets out in weeks. We could use the winter to develop an implementation plan with the stakeholders. We could deploy these in summer and scale up from there. It's a very doable project with wins on multiple levels. Thank you.
If the judges could now turn on their cameras, unmute their mics, and start asking their questions for the Q&A period.
Bob.
Yes, thank you for this intriguing proposal. Can you tell us more about the contents of the basket and how they would function? I presume they'll provide habitat for various kinds of organisms and possibly some remediation of some of the problems in the water. But I'd like to learn more, a little more about those contents.
Yeah, good question. So all of those things. And the intent of the basket is to be adaptable for what's needed at that specific site. So you may need to have one floating high in the water with, to get turtle eggs, for example. So it would be filled with sand. And we could line the basket with, say, miner's moss and some other things to make that sand substrate stay in there. You may want one sunk down 2 feet, so it could be a spawning site for sunfish and those types of things. It really is meant to be adaptable for the specific requirements of the river. They all have different headwaters, and they all enter the lake in different things, so they have different opportunities and needs. Like Maumee is trying to get sturgeon back, right? So that could be geared towards providing habitat for those fingerlings to be successful in that Maumee River, and it would go from there.
Have you estimated the lifetime of these kinds of materials in the baskets themselves? And you have a proposal for harvesting them or recovering them when their life ends?
So fire hoses, it's a double wall jacketed fire hose, and they're extremely durable. They're used in marinas today as dock bumpers and the sort of things like that. So they're extremely durable. Do I know when those end? I do not. And yes, they will require some type of life cycle maintenance, but again, not everything's free, and you're putting together a lot of habitat to build these things, and there is cost associated with it.
Thank you.
Mike, can you hear me?
Yes,
This is
Michael.
Mike. Yeah, just curious, you mentioned the value was $1.75 per cubic foot.
Yep.
And I think you just referenced cost. I was hoping you could maybe go a little deeper on what the cost is per basket, even though it is recycled fire hose material.
Okay, so the cost is about 100 cubic feet is generated out of that. So we're assuming that it's roughly, if the basket is 24 by 18, which is like the size of a Sterilite container that you can get at Target. Assume you get 3 feet above it and 3 feet below it, 18 inches round. That's where you get to the 100 cubic feet. Now, the cost of the fire hose, the backer, and the materials to put it together is about $170. If you were to just buy it straight off of shelves today. So that's where that $1.70 per cubic foot number comes from.
Gotcha. Okay.
Okay.
That answers it. Thank you.
I don't
Go
see
ahead,
any.
Bobby.
Hi, just wondering, you had mentioned partnering with the EPA and schools and different working groups. Have you engaged any of them to see what their interest is in doing this type of project?
Yeah, I've spoken with, I've used the Cleveland Metro Parks as a mentor, and they're doing some different things along the Cuyahoga River. They're doing a lot of work behind the bulkhead, and they've done some work in association with the Cleveland Museum of Art to attempt some gates, for lack of a better word. So there's some interest there. I don't want to speak for them, but yes, I worked with them, and I also worked with the Northeast Ohio Sewer District, and they were part of the teams that have attempted it in the past, and I learned a lot from them. Donna Freeman is who I was talking with there, and so there is interest there as well in terms of pushing it down to a school level, to camps. I've not pursued that avenue yet.
Thank you.
Sure.
All right, we are out of time for questions. So I'm going to take it back to Mark to introduce the next team.
All right, thank you very much. And if you want to just drop some comments in the chat in terms of have some excitement, have some fun, go ahead and do it. All right, please feel free to do that. That was our very first team, the Island Hoppers, and thank you very much. We appreciate that part of the presentation. Thank you, judges, for some fine questions. And next up, we'll hear from DAMPR, and DAMPR will be joining us right now. And team DAMPR, whenever you're ready, please turn on your cameras and mics, share your screen, and begin your pitch. And as soon as you'll start, we'll start with our 5-minute timer. Please welcome team DAMPR. All yours.
Hello, everyone. Good afternoon. Thank you for introducing us. We are Team DAMPR. I'm Dr. Varun Kasarneni, and here's my team. We are from Gannon University. The problem we're trying to address, microplastics. Microplastics are pollutants of great concern in Great Lakes and around the world. The presence of microplastics not only harm fish, other aquatic life, and birds, but also result in several water quality issues. Further, microplastics contaminate food supply and act as reservoir and conduits for several other hazardous pollutants into ecosystems. Studies have shown that Lake Erie has the highest concentration of microplastics among the Great Lakes. And a large fraction of microplastics found in Great Lakes and other surface water bodies are under 2 millimeters in size. An estimate there shows highlighted about 80% of microplastics are under 2 millimeters in size. Currently, there are no technologies that are available to remove these microplastics from lakes and other surface water bodies. So the solution that we are proposing is DAMPR, a device that could effectively separate and collect microplastics in the size range between 280 microns and 3 millimeters from the surface of the lake up to 2 feet below the surface. DAMPR could be programmed, so we could change the parameters based on the size that you want to collect, size of the microplastics. The parameters could be changed, and also operation times based on where this is deployed, the location, the weather, the battery life, everything could be programmed into DAMPR. We're confident that the separation mechanism will have minimal or no impact on plankton. We'll be using several filters so that the larger phytoplankton or zooplankton will not enter into the system. And the smaller ones, anything below 280 microns, will get filtered and cleaned periodically through a self-cleaning mechanism. It's going to be portable, so easy to transport and install at different locations. You could carry multiple devices on any vehicle or small boat. Some of the features of DAMPR include solar panels with lithium-ion batteries. It'll have both flotation and anchoring capabilities, so it could be installed in at different locations. We'll have multiple sensors in the system that could detect clogging and when the system reaches a maximum capacity, when it needs maintenance. Because of internet connectivity, you'll get text alerts or emails. The device, part of it will be above the surface of the water, roughly about 18 inches. And then on top of it, we'll add beacon lights so that it's visible constantly for people using lake for other activities. It'll also have a GPS tracking device and wave stabilizer so that it's not knocked off or it doesn't tip over. There are other features that we're thinking about adding as needed. As I said, the current version we're developing is a portable nearshore version. We could scale it up for a larger device for offshore, which will be much larger in size. With the nearshore portable version, we're estimating the cost will be somewhere in the range of $1,500 to $2,500. Here's a timeline, plan and budget allocation for each step. So we hope to finalize our design and have all the components and start constructing prototypes. By end of March 2022, we hope to have prototypes built and then lab test all the mechanisms. And then extensive field testing will be done in Presque Isle Bay in Lake Erie, Pennsylvania. Followed by any modifications with system analysis and a second round of field testing. And we hope to have final system design ready for deployment in multiple locations along with the operation manual. With the money that we can get, we plan to do a regional scale implementation. And then we're open for partnerships with several organizations for large scale implementation. So our partners during the development phase includes Gannon University Aquatic Marine Biology, Mechanical, Electrical, and Computer Science departments. For regional implementation, we are looking at partnerships with Regional Science Consortium based off of a Tom Ridge Environmental Center. And for large scale partnerships, as I said, we're looking for grants and large partnerships. These are some of the references we used. Thank you for your attention. Happy to answer any questions.
Thank you, DAMPR. And if the judges could now unmute their mics, turn on their cameras, and start asking their questions.
Yes, Bob, yes.
Yes, thanks. This is another intriguing proposal. So can you describe the technology you would use to distinguish the microplastics particles from phytoplankton and other living organisms of comparable size in such a way that you won't harm the living organisms in any way?
So there's no detection technology, but what we'll be relying on is the densities of different plastics and different phytoplankton, and then the screens, as mentioned. So the openings that will bring water into the system will be 3 millimeters in size. So anything larger than 3 millimeters will not enter the system. And the separation mechanism, I can't reveal all the details, unfortunately, but the separation mechanism will enable anything less than 280 microns will go out of the system. So we're dealing with a small fraction of phytoplankton or zooplankton that will be available in that range. We're looking at different distribution in Lake Erie in the literature, and actually tomorrow where our students are going out to sample the water and see what the size range exactly is in the current Lake Erie, where close to Erie, Pennsylvania. So that will resolve a lot of problem, take care of a large fraction of plankton that we'll see. Anything that's accumulated within the system along with the plastics will be collected, and we're looking at using it for biofuel production and other alternatives. Hope I answered.
Yeah, thank you. I have other questions, but I'm going to let other judges ask their questions first.
Sure.
Thanks, Bob. One question I have is, what determines where the device is deployed? Is it, what criteria is used to determine where the device is deployed?
So anywhere large amounts of litter is getting accumulated, there is no criteria. Anywhere you can deploy the device anywhere. The features that we are planning on having in the device will enable it to be deployed anywhere, but preferentially where you're seeing large quantities of litter floating in the water. That's where it'll be most effective. You'll be able to separate out large quantities of microplastics.
Thank you.
I have a question.
Yes.
Have you guys been able to dollarize the benefit with the technology?
I mean, costs?
No, not the cost, but the benefits of the microplastic cleaning. Have you been able to dollarize or put a financial benefit to the region with that innovation?
No, not a dollar cost. No.
It's mostly for health purposes.
Yeah, it's going to clean up a lot of water. So we're currently estimating if our system works for on an average 6 months in a year. In the winter months, we're not comfortable leaving the system out in the water. We're looking at filtering out roughly about 220,000 gallons to 360,000 gallons per 1 unit. So depending on where you deploy how many units, so that we can extrapolate that.
And maybe could you expound part 2? You mentioned a little bit about the reliability of your device. You mentioned, I think you would remove it during the winter, but I guess beyond that, how many years, seasons, and so forth would the device last?
So the materials we're planning on using, we're going to look at anything that's going to withstand all the wear and tear for a long time. But that's why we had like long testing time periods where we'll see what would be, how long the systems would stand in the water in the conditions that exist in different parts of Lake Erie. So that all those will be answered once we were able to test it, at least in 1 season.
Okay.
Yes, Professor, you answered my question that I was going to ask about sort of the impact that each unit could have in terms of how much it could actually filter.
Mm-hmm.
And so I guess the second question I have for you is, besides the work of filtering the water and the microplastics, which is a huge issue in our Great Lakes especially, is there any specific data that you hope to gain? You mentioned that it's going to have sensors attached to it. Is there any data that those units could measure, attain, that could be shared with the scientific community or with other leaders working on clean water technology?
Yes.
Is there another benefit that you see from this equipment?
Yes, definitely. I mean, on top of it, we could add additional sensors, like even for algal bloom monitoring, if there is something that could be added, we could add additional sensors to it. So we could constantly get data, real-time data when the devices are deployed. I'm also looking at another application for this is sample collection for research. So instead of deploying it for extended time periods, you could move the device into different locations for a certain time and then collect different size particles by changing the parameters of the separation mechanism. So there are definitely other applications. Once we have the device, if other researchers, organizations want to use it and modify it, we're open for that.
All right, thank you, DAMPR. That was all the time we had for questions. I'm going to give the judges 2 minutes to fill out their rubrics, and then we will get started with the next team, Life Magnetics. And
Thank you
judges
very
feel
much.
free,
Thank you.
and judges feel free to turn off your cameras and mute your mics.
As the judges are taking 2 minutes just to go through rubrics, let me just say this: there was a second team and second of 12 teams, and vying for $45,000. $45,000. Finals will be hosted by our friends at the Cleveland Water Alliance on November the 18th, and they will be vying for $45,000 in funding and support services. For those of you who may be watching on YouTube, thank you very much for joining us in other social media platforms. We really do appreciate you taking the time out of your busy afternoon to join us for this important Erie Hack pitch competition with 5 cities being represented. And you're in for a real treat this afternoon, right? So just continue to sit back. We'll be taking breaks periodically throughout this afternoon. And we'll continue to keep this process rolling very well. So again, my name is Mark S. Lee. I'm here in Detroit, and I'm a radio host, a personality here in town. I contribute to various media platforms, including television and radio here in Detroit. And I'm also an entrepreneur, and I own my own business, the Elite Group, which is a marketing organization headquartered here in Metro Detroit. I'm also an educator. I'm an adjunct professor across 3 universities here as well. All right, so I think, Felicia, are we set?
Yes, we are ready now.
Okay. All right, we're ready. All right, again, thank you, DAMPR, for your presentation, and feel free to drop your comments into the chat room. We want to engage you as well. We're going to move on to our next set of presenters, Life Magnetics, and when you're ready, please share your screen, turn your mics on, and the clock will start. Good luck. Share your cameras and your mics, please. Good luck to you.
Thanks. I'm already sharing my screen. Can you guys see it?
Yes, we can.
Okay, just checking. Since you were saying share your screen, I wasn't sure. All right, so I'm Dr. Kevin Hagdorn. Our company is Life Magnetics. We were funded in 2017 by the National Science Foundation to develop methods for shipping and storing RNA. Do you remember how with COVID-19, we weren't effectively able to do at-home testing and how the RNA vaccines needed to be stored at -80? So shipping and storing nucleic acids is a significant problem, and we're applying this technology to address some issues with PCR testing in our lakes and waterways. So talking to the stakeholders and other people involved in Erie Hack, we were able to identify a number of PCR tests which are done to assess the health of the lakes and waterways, which we can reduce the cost of by applying our technology. So for one, certain protocols, PCR protocols, are necessary to identify the origin of E. coli and fecal coliform samples if there's a bypass event. PCR is also used to determine if algae can produce toxins, which are a hazard to people. And also the existing methods for PCR testing actually don't assess surface waters. So talking to a number of groups, so they're actually done by looking at solids which precipitate to the bottom of the lake or bottom of the sample that's collected. But pulling nucleic acids out of a solid sample that's resting on the bottom of the lake or jar is not actually testing the surface waters, and that's an issue we can address. So we were funded by the National Science Foundation to develop a product to ship and store nucleic acids for testing. And we developed this product and we're deploying it in a couple of niche applications at this point. The technology works, so the graphene is coated onto a magnetic bead, and when nucleic acids are present in the with calcium chloride, they bind to the graphene nanoparticles and create this graphene nucleic acid complex, which is separated with a magnet. And this normally works on short single-stranded nucleic acids, but by varying the buffer composition, we can do longer nucleic acids. And with Central Michigan University, we were able to apply this to population surveillance of COVID-19 and its variants in wastewater. So on the right-hand side is our data with digital droplet PCR. With a single wastewater sample, we're able to identify COVID in all of its variants in wastewater samples. And the technique has been over an 80% cost reduction for doing this testing. So on the left-hand side, you can see the old method here. On the left-hand side with the method comparison is the old method where you take a wastewater sample and you precipitate down the solids, and then you run the solids through a traditional extraction method. In our method, you actually pull the nucleic acids directly out of the sample with these magnetic beads. And this cuts the process time down from 18 hours to 80 minutes. And with the automation platform that we hope to roll out, we can cut that down to about 30 minutes, which is over an 80% savings on labor time associated with this. And we've had 99% recovery of bi-6 virus, which are in spiking experiments. Our team has individuals located actually around the Erie Basin. So the two founders, myself and Rashad Kalla, were out of the University of Michigan, but we work with Ben Travis, who's the CEO of Caliber Scientific, which is a chemical manufacturing company in Toledo, Ohio, and more recently with Creative Destruction Lab and Amplitude Venture Capital, which are located at Toronto. Amplitude Venture Capital and Michael, with that group have committed to 4 hours of coaching a week to prepare us for VC funding. The two aims that we hope to accomplish with this project are one, demonstrate PCR testing for different bacterial samples. So our SARS-CoV-2 method for detection, SARS falls apart very quickly in water samples. So we're pulling out sort of dead fragments of the virus. We may have to adjust the method a little bit to detect bacteria, which live in the lake and are more complex. So we're going to deploy the funding to applying the method for reducing showing the same benefit for that type of testing as we did with COVID testing. And then as a second point, expanding the algae testing to include both RNA and DNA testing, which will not only show if algae are capable of producing toxins, but in what amount.
Thank you, but that's the 5-minute mark and I have to call time now. So if the judges could now turn on their cameras, unmute their mics and start asking their questions.
Hi, Kevin, this is Valencia. Really quickly, does the method detect other viruses beyond SARS-CoV-2? Because there is great interest in that for wastewater epidemiology. And then what is the cost of running the test versus the typical PCR extraction that can be done now? And last question was, were you able to do the gene sequencing? Did it assist with pulling off the gene sequences, or it just literally provided the SARS-CoV-2 and you all sequenced separately?
I'll have to do each of those. Hopefully I can remember all three of those questions. Please remind me if I miss one. But so this method is just pulling out the nucleic acid. So yes, we can do all of the different viruses. The reason why there's some question why we need development for applying it to bacteria is because with bacteria, the nucleic acids are inside of the cell, right? our carbon can't get to the nucleic acids unless it's outside of the cell. So the development method basically comes down to, are those nucleic acids, are there enough broken down pieces of those bacteria for us to collect the sort of material that's floating around in the liquid, or do we need to add some sort of chemicals, which we'd rather not do, to sort of break them open, right? So yes, it can be applied to all the viruses as long as we can get to the nucleic acids, which is the key. We have to figure out a way to get to the nucleic acids, which would be inside of the bacteria or inside of the viral envelope. COVID falls apart, so that's just available and it's floating around in solution. But for other stuff, we have to figure out how to get it out of the package, so to speak. For your second question, actually, I can't remember the second question. So let me do the third question first and then start back to the second one. So third question, that was not sequencing. So that was digital droplet PCR. And digital droplet PCR, the way it works is it makes lots of oil droplets, and each oil droplet is a capsule which does PCR. And in basically you're doing PCR thousands of times, and it will create those bubbles based on base mismatches. So no, that was not sequencing, but yes, we are able to tell the difference between all the variants without doing sequencing, which is more expensive.
Yes, that's brilliant. And the last question was just cost versus typical PCR.
Yeah, all the reagent costs are virtually identical. We're not pitching reducing the reagent costs. The reagent costs are all exactly the same as with the old methods. Effectively, the costs that we're reducing are the labor costs associated with preparing the sample. So in all the old methods, you have to precipitate down the sample and collect the solids and then run the solids through it. In our method, you're just adding these magnetic beads, which you directly pull out with a magnet. And so that's a lot quicker. And actually, ultimately, we would like to just do it on site where we sort of mix in those carbon beads, pull out the nucleic acids, and then rather than shipping full water samples, you're just shipping basically a little tube with the beads and the nucleic acids attached. Thanks for the great questions.
Kevin, quick question for you. Actually, just a comment first. I know the University of Windsor and the Great Lakes Institute for Environmental Research, GLEAR, does a lot of work on COVID testing and wastewater. So definitely recommend reaching out to Mike McKay at, again, GLEAR.
He was one of the ones who gave us feedback on this. So he was extremely helpful in directing our objectives. This wasn't the pitch that we gave the first time, but after talking to Mike specifically, we were able to refine it and figure out some of the issues with bacterial testing.
Oh, that's terrific, and appreciate that comment and that great cross-border collaboration. Who's your target user? If you can just sort of explain who you're targeting with this technology.
Yeah, so after talking with Mike, so one of the concerns that we had with applying this bacterial testing, it's easy enough to detect E. coli and other bacteria by culturing the bacteria. So one of the open questions we actually had for Mike was, is there a benefit to doing PCR testing on these various bacteria? And it turns out that there is, because, for example, with E. coli and fecal coliform in bypass events, you want to know the origin of where those bacteria came from. In order to do that, you have to do PCR-based testing. So even though in certain situations, culturing bacteria is cheaper than PCR testing, in certain situations, we actually have to do PCR testing to get additional information on the bacteria and where they came from.
I just wanted to add to that, Kevin. So can you just give us a situation where that type of information would be pertinent, would be valuable?
So those things are government regulated in both of those cases. So we were told that in bypass events, the phase 1 and phase 2 sites are required to do PCR testing in order to identify the origin. And then in the algae testing, they're required to perform the PCR testing to determine if the algae populations can produce the toxins. And so for the end user, both of those are actually federally mandated required tests for the sites. And we're making them cheaper, so we're reducing the cost for particularly the labor costs for those sites.
All right, Bob. Last question.
Can you tell us what the detection limit is? And yeah, well, that's good. Yeah, I think that's all we have time for.
No, it's complicated. So I can tell you that. So one of the problems with running the wastewater samples is that no two of them are identical. And so one of the best measures that we have is the doping measurements, where we dope in 5/6 virus additionally, in addition to doing the COVID testing. And then if we know how much of the virus we dope into the sample, we know how much we should recover. And when we dope 100,000 copies in, we can get 99,000 copy recovery. So we know we have 99% recovery in the surface water sample of the virus that's solubilized. But we don't know, a lot of the material is, for example, inside of any solids that precipitate in the bottom. So fecal sample that might precipitate to the bottom, in which case we're not actually going to recover that because it's sort of inside of a solid. We're recovering virus and other pathogen materials that are actually free and in solution. Right. And so it's difficult to put a detection limit number on that because a lot of the time we don't actually know how much we have in the input material if we just take a wastewater sample.
Okay, thanks.
All right, thank you all. I will give the judges 1 or 2 minutes and then we will move forward with our next team, which is the Water Warriors.
And as the judges are taking 1 or 2 minutes, just a reminder, feel free to drop a comment in the chat. Feel free to, share your favorite team, your favorite city. We have obviously Detroit and Cleveland and Windsor, Buffalo, Toledo. Feel free to, drop your comments in the chat in terms of cheering on your favorites. Okay, so this is a great opportunity. We know we're doing this virtually, and just have some fun with that in that respect as well. We thank our judges. They're just taking another 30 seconds ago. That's right. Go Cleveland. I see Cleveland there. Okay. All right. That's all about somebody say go Detroit. So hey, come on, let's make it happen here. But we have outstanding judges representing these 5 great areas, if you will. And what we're going to do now is to continue and proceed with the Warriors Water. Please share your screen and turn your cameras on and go for it. You have 5 minutes for your presentation.
All right, thank you. We're water warriors, and we're treating water how we think it should be treated. The problem we're solving is nutrient contamination, namely phosphorus and ammonia, and it's everywhere. This map shows the nutrient pollution from agricultural runoff into the Mississippi River Basin. The pink spots are the cities, and the green is all the ag runoff. The EPA calls nutrient pollution one of the biggest and most expensive problems. And Lake Erie is only getting worse. The EPA designated it as an impaired body of water, which means in regulatory terms that the chemical pollution filtering in through local tributaries is getting worse every year. Water Warriors is a small startup that provides solutions to fight nutrient pollution, to absorb it, to get it out of the water, so issues like algae blooms and loss of marine life never happen. And then we return the nutrients to the land as a slow-release, nutrient-rich fertilizer. So we develop Poseidon pellets, pellets that are able to absorb phosphorus and ammonia on contact. And here's how it works. Water simply flows through our insoluble pellets, and the phosphorus and ammonia stay behind. When the pellets reach capacity, the nutrients are returned to the land as a slow-release fertilizer. We developed this through a CRADA agreement. Oh, sorry about that. A CRADA agreement, a cooperative research and development agreement with the EPA, and Water Warriors holds the patent in our IP. Poseidon is designed for both point and non-point sources like farms and waterways, stormwaters, wetlands, point sources, industrial municipal plants. And these are the markets we serve. And the reason why is their pain is the same. The fines, the lack of solutions out there are the same from a wastewater treatment plant to a family fish farm to edge of field runoff to stormwater and even wetland protection. We can make Poseidon wastewater and Poseidon ag stormwater. It's scalable and we can package it in multiple ways. Poseidon stormwater has a retention time of 17 seconds. These pellets are fast. They need to be. You can't control the flow rate of a storm event. They cost less, but have less capacity. It's a speed and capacity trade-off. Poseidon wastewater has a retention time of 10 minutes. The capacity for these is off the scale. They cost more, but use fewer pellets and are calculated to last 12 months. Here, capacity means more than speed when you can control the flow rate and the retention time. And there's competition out there. For wastewater, it's companies like Veolia and Ostera who charge millions of dollars in infrastructure to precipitate the phosphorus and ammonia using the exact same chemical reaction. And then for ag and stormwater, there's materials like biochar, zeolite, and synthetics like Phoslock. Ours has the speed and the capacity others don't. And here's an example. A sand filter was retrofitted with 500 pounds of pellets at a treatment plant in the UK. It was able to remove anywhere from 75% to 90% of the phosphorus, so they were able to meet their limit. Poseidon stormwater is designed to be used in existing stormwater structures. You simply replace the sand or other media with our pellets. Poseidon pellets can also be used to treat ag runoff in what is known as a P-trap. These were developed by the USDA. It's essentially a French drain that can use our stormwater media. The P-traps can be connected to tile drainage, drainage ditches, anywhere that phosphorus runoff can be diverted into a contaminated area. And there's only 3 parameters: the amount of media needed, the flow rate and contact time, and the ability to replace and reuse the media. The USDA has even developed an app to design them. It calculates everything you need to make a perfect P-trap, from the slope to the depth to the amount of media. It's really well done. And we've completed 3 wastewater treatment pilots. We saw removal rates of 90% using our pellets in a sand filter. We're working with the USDA and EPA on this technology, and we'd like to show you what our Poseidon pellets can do. Thank you.
If the judges could now unmute their mics, turn on their cameras, and start asking their questions.
John, one real quick question. You talked about the percent decline based on, but what was the concentration? What was the effluent concentration of the phosphorus after use of the media?
So in the UK for that pilot, they were going anywhere from 10 to 15 on the influent milligrams per liter and trying to get down below 1 on the effluent. So with wastewater, there's different levers you can control: the flow rate, the retention time, the amount of media. So you have a lot of variables where you can get as much removal as you want if you've got the right amount of time. And for wastewater pellets, it's 10 to 15 minutes is usually the sweet spot. If you want 90% removal, it's going to be around 30 minutes. But again, that if you had more media, it's a trade-off. More media means less retention time.
And one other quick question: does the media have to be replaced after every event, or is it recoverable?
It's recoverable. And what we do is we try and estimate using our simulation models of 12 months of use for the amount of media we provide. For stormwater, we'll go as high as 2 to 3 years, just because accessing urban stormwater systems isn't a easy thing, to say the least.
John, did you say that the medium is going to be used as an agricultural additive at the end of its life when it's done collecting the phosphorus?
So the wastewater media reacts with incoming phosphorus and ammonia, and only those two. And it forms struvite, a slow-release fertilizer. It's a well-proven slow-release fertilizer. So companies like Veolia and Ostera will use like a magnesium chloride to bond with those two, and then precipitate it out in their multi-million-dollar piece of equipment. whereas we use an insoluble pellet that has the same struvite reaction within the pores. So we're creating fertilizer as it picks up the phosphorus and ammonia. So in 12 months, oh, I'm sorry.
No, I was just going to ask if there's been any application of that on a farmland or for actual use.
We're actually engaging with the USDA Soil and Research Lab in Indiana with Dr. Penn there to do just that. So we're looking into the agriculture runoff right now. As I mentioned in our presentation, we've done a lot of wastewater pilots, but we want to get some ag pilots and stormwater pilots as well.
Thank you.
Have you done cost benefit estimates? In other words, what's it going to cost to remove a certain amount of phosphorus and ammonia, and compared that to cost benefit for Austera and some of the other technologies that are available? Yeah.
And so we don't fit into the large wastewater treatment plant systems. You know, they can afford the $10 million for one of those systems. Okay. We are more in the medium to rural wastewater where they don't have the funding for that. So ours are actually really cost beneficial per pound of phosphorus removed. And it's designed for a wastewater plant where the operator is also the postman and also the mayor, you know. And those tend to be in agriculture rich areas where all of that phosphorus is coming into the treatment plant from the tile drainage.
So this is simpler to operate is one of the advantages.
It is mindless. It's you can throw a sock down of pellets. It's anywhere that the pellets can, or any how the pellets can be contained, they'll work.
But the cost of production?
It's not bad. We outsource. We have 44,000 pounds of material in storage right now of raw materials. So we warehouse and kind of, switch out the inventory when it starts to get low, replenish it. So it's a revolving inventory of that much.
Pound for pound, how much phosphorus can you absorb with a pound of your material?
Anywhere from half a pound to a pound. It all depends on the conditions. If there's an equal amount of phosphorus to ammonia, then you're forming struvite. If there's only phosphorus, then it's a slower reaction and less capacity, but still a great pellet. Most of the treatment plants that we've done pilots in had no ammonia in the water.
Right, it's
already removed. Yeah.
All right,
and
Eric.
it retrofit it into any kind of device like a sand filter or any aggregate filter for the most part.
Thanks.
All right, Eric, your question will be the last.
Yeah, quick question, John. Any of this process or technology is patented?
Yes. We have a credit agreement with the EPA, a Cooperative Research and Development Agreement. And with that, we were able to assign the patent under Water Warriors IP. So if you've got Google, look up Water Warriors patent and you can read all about it. Thank you.
All right, now we'll give the judges 1 or 2 more minutes to fill out their rubric.
And thank you, Felicia. As we continue, again, who's your favorite team? Who's your favorite city? Drop it in the chat as we're doing this as well. We just appreciate you if you're watching on YouTube and other social media platforms. We hope you're having a wonderful afternoon and learning something from this important competition. Our next team, certainly, again, I want to thank Warriors Water. Our next team will be Stark Drones, and they will be the final team before we take a quick break. So they will give their presentation. We'll have Q&A from the judges, and then at that point, we'll be taking a brief break. So if you're ready, our friends from Stark Drones, please share your screen, mute your mics, and good luck.
Can you hear me?
We hear you just fine, thank you.
But can we give just a few more minutes for our judges, please? Thank you.
Okay, thank you.
Judges, are we ready? All right, whenever you're ready then.
Okay, I'm gonna start now. I'm working on underwater wireless sensory networks. In the past, I have built numerous variations of underwater wireless sensory networks in order to collect real-time data about oceanic contamination. This time I propose another real-time sensory network that utilizes various upgraded telemetry techniques as well as an extra data syncing peer. The problem that I'm trying to fix obviously is the risks related to contamination. Timing, so chemical and wet testing methods could take up to 24 to 48 hours alone. We're trying to do real-time monitoring as well as reduce the risk of human error, as well as productivity in regards to targeting mineral offloading and things like that when you're able to have better sensors and networks. So some testing methods cost over 30 grand in regards to wet and chemical testing. This is a lot of times out of your taxpayer dollars. And according to the WHO, over 485,000 people a year from mostly third world countries die from lack of clean drinking water. We obviously want to fix that. My previous solutions, so the costs in regards to previous solutions I made were much lower compared to competitors. For sensors, the cost was around $125 to $150 in parts for a device that extracts real-time data. That's in comparison to the 30K devices out there. The signal strength was in real time underwater, and the results allowed for higher data extraction efficiency. The first solution I built had a problem with enclosure design and deployment. I fixed that problem, and I have created an improved method for signal processing through an optimized sonar conversion. Tests so far have been basic lake deployments for previous solutions, and a lab environment testing is available with access to higher funding. You can see the various different prototyping phases, including this device right here, which is a telemetry module that replaces a device that's literally the size of a fridge and tens of thousands of dollars. We've also created our own telemetry protocol for underwater wireless networking and created different sensors and even created a dashboard and data monitoring apps. In the future, we eventually want to have different telemetry modules deployed across lakes. And we eventually want to have a robotic mechatronic system that deploys different sensors that are built with synthetic nanocomposite alloys that float based off of the pH of the water. Currently, I have intellectual property protection for software related to this, and working on getting protection related to the different nanosensors, the different sensory designs, as well as the different modules that I built. This technology have been presented in front of the Department of Energy and Environment, Gigabit DCX, Lakebed 2030, top scientists at NASA, and even at Maker Faire Detroit. The solution I built was, in regards to data syncing and transmission, was an upgraded sonar conversion method that implements a P2P sensory network, as well as an upgraded mesh like parallel processing architecture. And eventually I want to have these sensors connecting to hydroelectric wireless grids instead of what we have here, which is currently lithium ions that's rechargeable. So something like that would be possible in the future with access to higher funding. We also have our own prototype and different board designs. Eventually, we can tackle lots of things with mass spectrometry sensors, and we've designed those as well as software-defined networking telemetry modules that work with those. Currently, as I said, we have a robotic system in place that we want to deploy tens of thousands of free-flowing sensors. This is highly scalable. Apparently, one of our insane goals is to automate cleaning for Lake Erie by 2024. And eventually we want to literally clean up the entire ocean by 2030. It's overly audacious, but the technology is currently there. In regards to the technology, we can currently offload signal data and networking catches through P2P networks. We've built a telemetry module network that works better than what's widely available. And we even created a protocol for power up optimization and when these sensors should be turned on and off. And these are our sources. So to summarize, we built telemetry modules, we built cost-efficient sensors, And now we just want to basically create an underwater Internet of Things. Thank you. And now I'll leave it to the judges for a Q&A.
If judges could now turn on their cameras, unmute their mics, and start asking their questions. Thank you.
Andrew, can you tell us some of the specific things that you can detect with this, and how do you have a peer-to-peer network out in Lake Erie?
Currently, some of the specific things we could test is usually traditional things with mass spectrometry, like we could test the different phosphorus run-ons, nitrate level, harmful cyanobacteria. Currently, we're trying to expand our testing on other things besides that. In regards to how I have sensors deployed on Lake Erie, I have some test deployment sensors that I've done in the past. And most of the tests I've done in regards to data is in relation to the telemetry protocol and how good the signal strength is in terms of underwater, because as you may know, due to the Doppler effect, something like that is extremely hard to do. And there's other telemetry modules and sonar already out there in the market, but they are highly expensive and unattainable for the average consumer. We, having this for under $200, basically made access to underwater Internet of Things available to not just massive amounts of companies, government agencies, but we also opened up the citizen science and hobbyist market. And in regards to the technology related to the sensor, I could show you something real quick in regards to how it's possible.
Mass spectroscopy requires high vacuum and a strong magnet and complex electronics. How is that possible underwater?
We're able to do this using nanotechnology. The main thing is really in relation to the actual telemetry protocol. So the technology that we focus on is more towards the wireless networking aspect of things, but we have different quantum chemists that are working with us, as well as people that are working on custom nano composites and things like that. So that's really what's available. In regards to the technology for data processing and syncing, I have a patent granted related to data compression. And basically, we're able to not just do the conversion with sonar, but we're able to release nodes that's able to compress signals and optimize strength underwater.
Okay, thank you.
Any other questions?
If there aren't any other questions from other judges, I understand you've achieved data compression, but that's not mass spectroscopy.
No, this is in relation to the underwater wireless telemetry protocol. So this is relation to wireless networking type of thing. The relation to the mass spectrometry method is more of what we want to do with nano composites. Right now, most of that technology is highly theoretical. What we do have is more of like basic pH sensors and stuff like that, but we do have different sensitivity sensors that are based off of different nano composite alloys that we are trying to do some tests on. And those sensors are also relatively cheap to build. In regards to producing those, we don't have funding available for that, so that's more towards the future. But the fact is, I do want to say on the record that that goal is attainable, and the telemetry modules we have in regards to networking that have been built already is already much cheaper than what's out there in the market, and we're able to achieve remarkable results just from a computer science perspective and what's possible in regards to sonar and signal strength in relation to underwater telemetry.
Okay, thank you.
Okay, if there are no more questions, we will go ahead and start our 5-minute break. We will be back at 3:21 p.m. for our next pitch with Blue Lion Labs.
Turns to sun rays, and on we'll go through the wastelands, through the highways, and on we'll turns to sun rays, and on we'll go through the wastelands, through the highways, and on we'll turn us to thousands, and we'll grow in number, fueled by them to see the horizon, turn us to thousands, and on we'll go through the wastelands, through the highways, till my shadow turns to sun rays, and on we'll go through the wastelands, through the highways, and on we'll go. I live inside my own world of make-believe. Kids screaming in the cradles, profanities. I see the rode through ice covered in bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe.
Welcome back, and quick break, and we had the first round of presenters. We're going to go into the next round of presenters. And at this time, I'd like to turn over to Blue Lion Labs, and we want you to take the opportunity to share your screen, to obviously turn on your mics, and feel free to jump into the presentation whenever you're ready. And again, if you have a favorite group, favorite city, drop it in the chat room. We're going to continue right now with our friends from Blue Lion Labs. All yours.
Hello, everyone. I'm Jason McGlynn, the CEO of Blue Lion Labs. At Blue Lion Labs, we're building a microfluidic chip to detect cyanotoxins in water. I want to start by asking you a question. What was the first thing you did after you woke up this morning? Well, maybe you had a cup of coffee. You probably brushed your teeth or had a shower. Well, I bet that within the first hour of your day, you used water.
Jason. Do you still need to share your screen?
Oh my goodness. Yes.
Okay.
Am I allowed to start over?
Yes.
Okay, apologies. I thought I was. Well, that's embarrassing. Thanks for letting me know.
No problem. Wonderful. We can see it now.
Okay,
Yep.
hopefully this will make things better. Thanks for letting me start over. So, rough start. I'm Jason McGlynn, CEO of Blue Lion Labs. We're building a microfluidic chip to detect cyanotoxins in water. So I want to ask you the same question again. What was the first thing you did after you woke up this morning? Well, maybe you had a cup of coffee. You probably brushed your teeth or had a shower. Well, I bet that within the first hour of your day, you used water. Now I want you to imagine that the water you drink from your tap is not clean or safe to drink, but that it has invisible toxins. Toxins produced from a harmful algal bloom. But what exactly is a harmful algal bloom? Well, harmful algae are when different types of cyanobacteria grow out of control in water. They can produce different types of toxins, like hepatotoxins or neurotoxins, causing damage to our liver or nervous system, and they can even be fatal. But these toxins are not only affecting our drinking water, they're affecting our recreational use of water and the fishing industry. It's estimated that the US spends around $4.6 billion a year dealing with harmful algal blooms. In China, around $6.5 billion a year. And with climate change, these blooms are only expected to get worse. So what happens if you're a water utility and you have a harmful algal bloom? Well, you have to take a water sample and send it to a lab. And at that lab, they use expensive equipment to determine the types of cyanotoxins and the concentration of those toxins. This process normally takes days, and it results in reactive decision-making by these water utilities. At Blue Lion Labs, we're building a microfluidic chip that takes in a water sample and then uses image recognition to determine the type and concentration of the toxin. On the bottom left there, you can see our lab prototype. Here, we're taking in a known amount of toxins in the water, as well as microbeads. These are then mixed and then concentrated. And on the bottom right, you can see these concentrated microbeads under a fluorescence microscope. The fluorescence of these beads is directly related to the concentration of the toxin. The benefits of this technology is that it's on-site and it allows for real-time analysis, all while being at a lower cost compared to sending it to the lab. Ultimately, this enables proactive decision-making by water utilities and key decision makers. The team consists of Dr. Mala Pudina, who's a professor at the University of Waterloo, specializing in electrical and biomedical engineering, and she's an alum from Stanford. Hamid is working on this project full-time for his master's thesis, and he specializes in microfluidics and chemistry. Katie has a PhD in algal taxonomy and is the COO of Blue Lion Labs, and I have a PhD in machine learning and data analysis, and I'm the CEO. In order to take this technology to market, we're going to leverage Blue Lion Labs' current infrastructure and technology. Currently, we're deploying an algal monitoring system that we're selling to fish farmers globally. We can use our networks and resources to sell this toxin monitoring technology. We've been talking to water utilities in Canada, and we have one here in Ontario, where we're based out of, on Lake Erie, that wants to trial this technology when it's ready. The business model for this technology is twofold. First, we'll sell the one-time device, which can be used in the field. And the second is recurring revenue coming from consumables like refillable cartridges and microbeads. We need funds to get our lab prototype into the real world testing. And we also need funds to file our provisional patent for this technology. We are Blue Line Labs. We believe everyone deserves to know if their water is clean and safe to drink. Thank you.
Thank you, Jason. If the judges could now unmute their mics, turn on their cameras and start asking their questions.
Sure, I have a question. Go ahead, Bobby.
Oh, just a real quick question. Is there a reason that you were focusing on aquaculture facilities instead of the lakes in general?
Sorry, for this toxin detection system?
Yeah.
Yeah, it's because the toxins are regulated by the US EPA, and the water utilities are regularly sending samples to labs to detect these toxins. Katie, you want to jump in?
Yeah, I just want to clarify. We're not developing the toxins for aquaculture. We have a different technology that's algae based for aquaculture. The toxin detection is specifically being developed for drinking water in and around the Great Lakes.
I guess just to clarify, the toxins in the freshwater environment are different than the marine environment, and this technology is for freshwater.
Yeah.
Yeah, my question was on the field device. Do you have a sense of the size of it and a cost of the field device?
Yeah, so right now it's all lab prototype, but our lab prototype, as you can see from that one image, could fit in our hand. So it would be ultimately quite small. And the cost, I don't know, Hamid, are you?
Yeah, I'm here. Sorry about
Okay.
that. I don't know why my video is not working. So the cost, it's like it's PDMS. It's really cheap. The cost would be $2 per chip.
Quick question. What is the time to run the sample versus the traditional lab methods? Because most water treatment facilities have labs on site. And, you know, especially large water treatment facilities.
Can you answer that?
Yeah, for sure. So what we have in the lab, our current test, it usually take half an hour. But I mean, in the next prototypes that we will have for our device, we can reduce it for 15 minutes. That's our plan.
Can you tell us sensitivity and specificity? For instance, which toxins can you detect? Can you distinguish different toxins? And in particular, can you distinguish different congeners, for instance, the microcystin, since different congeners have substantially different levels of toxicity?
Yeah, so we are using antibody in our assay, which is highly selective. So we will be able to selectively detect the toxin type. So it will be considered. And the sensitivity, so our base is what World Health Organization have been proposed for a safe dosage for microcystin, and we will use that in our assay as our base. And we would try, and we will go lower than that concentration for our device.
Our target sensitivity is 0.1 microgram per liter. Can you confirm that, Hamid?
Yes, yes.
Yeah, and with regard to specificity, right now it's MCLR, but we're also looking at cylindrosporops and liposporops.
Yeah.
Yeah.
And are you detecting antibody binding electronically or chemically?
They're binding chemically.
Thank you.
We have time for one more question.
So if we have not a question, I just want to clarify that there is a guideline for World Health Organization that is suggested dosage for microcystin. So this is our base for sensitivity. We will use that, and we will go lower than that base. I mean, guidelines to have a good and sensitive chip.
How close are you to that right now with the existing technology?
We are even lower than that. I mean, it's 1 microgram per liter. 1 milligram per liter, and we right now we are detecting 10 times lower that concentration.
Very good. Thank you.
If there are no more questions, we will give the judges 1 or 2 minutes to fill out their rubric, and then we will get started with the next team, RNA Power.
Okay, thank you, everyone.
Thank you.
Thank you. Judges, feel free to turn off your cameras and mute your mics. And Mark, I'll let you take it away.
Thank you. As the judges are doing that, I want to make sure we acknowledge them. We want to thank them for their time as well. Obviously, everyone's busy, and they have certainly taken some time out of their busy schedule. The judges are representing Toledo, Dr. W. Robert Midden, research professor in chemistry at Bowling Green State University. Representing Windsor is Mr. Eric Kuzbierczyk. He's the member of parliament for Windsor-Tecumseh. Representing Detroit is Valencia Mobley, PE, and she's deputy director and chief engineer of the Detroit Water and Sewage Department. Representing Buffalo, Bobby Coleman, and she's a senior sustainability manager of NOCO, Energy Corporation. Representing Cleveland, Mr. Michael Shum, vice president of product development at Moen, and we want to make sure we acknowledge them for their time this afternoon. And again, what you're doing is we're watching the presentations today for a chance to go to the finals, which will be hosted by Cleveland Water Alliance on November 18th to compete for $45,000 in funding and support services. And we want to take the opportunity to also thank the most recent presenter, Blue Lion Labs. And next up is, as we continue the pitch competition, thank you again to Blue Lion Labs. I want to present Penn State Environmental Systems Engineers. So we'll hear from them next. Whenever you're ready, please turn on your cameras and mics, and please share your screen and begin your pitch. And when you do, the clock will start.
All right, we're all set. All right. Good afternoon, everybody. We are Penn State Society of Environmental Systems Engineers, and we will be presenting our topic on eutrophication, a biochar solution. Algal blooms have threatened the lake's ecosystem for decades. As fertilizers and industries continue to pollute our lakes, we must find new innovative ways to reduce our impact. This leads to our problem statement. By adding biochar to various regions of the lake, we are able to lower nutrient levels and reuse the mass for fertilizers. What is biochar? Well, biochar is a black carbon produced from biomass sources. It uses carbon sequestration to reduce nutrients, and it has a high surface area and porosity, as well as a low ash content. This helps regulate the acidity and nitrogen bleaching levels. This can then be reused to enhance soil structure for crops. But how does this work? Well, biochar's absorption rate helps remove nitrates and phosphates, as well as heavy metals from low bodies of water. For our project, we will be researching how biochar works in removing nutrients from shallow bodies of water that are affected by heavy amounts of phosphates and nitrates. More specifically, direct point sources such as dairy farms. We aim to study the effectiveness of biochar to remove pollutants from runoff and when subjected to stimulated variations in climate, whether that being coexisting ions of pH in the water and temperature ranges. All of these are independent variables that affect the absorption capacity and effectiveness of the biochar.
So how will it help Lake Erie? For stormwater application, it has been studied that biochar has helped reduce contaminant levels and retain water, which can be reused for the reuse and stages of saving water. At lab scale, it has been shown that biochar is effective to remove phosphates and nitrates from water and wastewater. We will use this capability of biochar to remove phosphates and nitrates from contaminated flows, which are going into the lake. This will allow the lake to heal itself, since this nutrient load will reduce excessive algal growth. At some point, the phosphate and nitrate removal capacity of biochar will get consumed. So we will replace the biochar with pristine biochar. But the used biochar has a very important function because it now contains the phosphates and nitrates, which are essential nutrients for plants. We will reuse this biochar as a fertilizer since it has been shown that these biochar release nitrates and phosphates slowly to enrich the soil. Also, they help in improving the moisture retention capacity of the soil. Research has shown that biochar has improved crop yield for up to 25%. Hence, with this approach, we do not have to worry about the safe disposal of biochar.
For our action plan, we will first use contour maps and hydrological data to identify the Lake Erie watershed and the various entry points for runoff. Literature data along with on-site sampling will provide us the phosphate and nitrate load from these points. We can then design treatment plans at these entry points based on this data. We will use probes to measure the influent and effluent concentration of phosphate and nitrate. A system of online monitoring of the influent and effluent will be developed, which will help us in keeping track of multiple plants from a central control location. Finally, to reduce the cost of biochar, we will use locally available agricultural waste to produce biochar. In essence, our solution uses waste to solve the issue of phosphate and nitrate, and then uses these nutrients to enrich the local soil. Thank you, judges, for your attention, and here is our contact information. Any questions?
Yes. How do you ensure the biochar doesn't absorb pesticides, herbicides, hormones, antibiotics, heavy metals, other kinds of harmful substances and in fact concentrate those from the flow, because it is used for those kinds of purposes also?
With our studies, we were thinking about happening to find it using certain chemicals to submit the biochar to be able to absorb the proper nutrients, whether it's going to be phosphates or heavy metals. Something more specific is what we would be looking after.
Thank you.
Have you looked into technologies to create the biochar?
Have we looked into the technologies? No, we have not looked into the technologies. We think that based off of some of the feasibilities would be purchasing in bulk, whether it be in bags or is it just as coming in flow as buying in bulk? Yes.
So I guess going kind of back to what Bob said, do you have defined characteristics of what the biochar will need to be for this process?
No, we have not defined it yet.
Can you talk more about the application and use of the biochar? Is it going to be in some type of bag or filter system that you can easily remove from the water that you're putting it into, or what does that look like?
I think the most feasible option would be using it into bagged sources where they would be able to absorb it and then be able to take out the bags and being able to reuse it by applying it as on layers into the crops as well, by placing them in the direct point sources, wherever it's going to be coming from at the highest entry level.
Others have also proposed using biochar for applications like this. How does your proposal differ from these other applications?
Well, I think the best aspect of this is being able to reuse the biochar. I don't know if the other groups have aimed at doing the same thing, but our research indicated that it would be best to apply them in the correct locations using, as Axel stated, using certain types of maps to find where the highest streams of runoff are coming from and applying them there in order for the best concentrations.
Thank you.
We still have time for one or two more questions. All right. Well, thank you, Penn State Environmental Systems Engineers. And we will give the judges a few minutes to fill out their rubric, and I will let Mark introduce the next team.
Thank you.
You're welcome. Thank you for joining. All right, thank you. I think I'm back now. I apologize for some reason I got disconnected. What I was going to say is very quickly before we go back to our next presentation, someone made a comment about the Buffalo Bills, and congratulations on them having a good season, and congratulations. But I have to say, as a Detroit Lions fan, okay, we're hoping just to get one victory. So we'll see what happens with that. So to you, the fans of the Buffalo Bills, congratulations. Keep up what you're doing. And we want fans for these presentations today. So feel free to drop your comments into the chat room if you can, whoever you're supporting for your favorite city as well. We're going to continue with RNA Power. Next up, we'll hear from them. And whenever you're ready, you can please turn on your cameras and your mics and share your screen and go ahead and begin your pitch. And Felicia will start the clock at the appropriate time. All yours.
Okay, looks like I've been added as a panelist. So now let me prep my screen. One moment, please.
Thank you. You'll just go ahead and share your screen.
One moment. Okay, is everybody seeing my screen now? I'll take that as a yes. Okay, I'll go ahead and get started now. Hi, everybody. I'm John. I'm representing RNA Power today to tell you about the power of RNA, specifically for aquatic ecosystems in Lake Erie. This is our team today. My background is in molecular biology. I was working in biopharmaceutical development, early stage cancer diagnostics for a long time, and transitioned a lot of those cool technologies into environmental action whenever I formed the company EQO with my co-founder Erica, who's a molecular ecology expert. On this team for this project, we also have Gary Anderson, who is a senior scientist at Lawrence Berkeley National Laboratory, and the CTO of a company called Veriset that has a really cool microbiome solution that we're going to be looking at. And Marite Ball is the business executive that we have on our team as well to make sure that this is actually a feasible, useful solution that can actually scale. So why do we care about harmful algal blooms? Well, in the city of Toledo, there were about 400,000 people who did not have access to clean drinking water for quite some time, and it was a bit of a crisis. And this isn't just a problem with economically, it's a problem for human health and public well-being as well. So as mentioned before, 400,000 people without water is a big problem. Just in the Lake Erie Basin, the lower basin, we expect $71 million to be spent on harmful algal blooms in a year. That was 2015 numbers. And in Canada, they're looking at $5.3 billion over 5 years impact from harmful algal blooms. They are a threat to public health as well as water quality, and they're somewhat unpredictable, not just in where they're going, but the big question that we're going to answer today is how to determine how toxic and severe these blooms can be. So, currently, what do we do? Right now, we can do some pretty cool stuff with satellite imagery and some fluorescent monitoring to look at where blooms are going. And we create these models to figure out where they're going to be. And on the back end, after they've already become toxic, we can detect the proteins through methods like ELISA and mass spec to look at how much toxin was dumped in. But in the middle bit, what's going on within the community, we don't really currently have a way to model that. So we're filling that gap. All of the other solutions are absolutely necessary. What we're doing is a technique that focuses on something called RNA. Now, specifically messenger RNA. This is a bit complicated, so I can get into this in the Q&A later if you want to get into the technology of it. But essentially what this allows us to do is not just know what toxins, what cyanobacteria is blooming and where it's blooming, but what toxins and how much toxin is being produced within the cells. Additionally, with Gary's work at Veriset, we can look at the entire microbial community. As we know, anything that happens with an individual happens within a society, and it's the same thing with microbes. Anything that happens to one microbe is going to be impacted by the people around them. And so if we can monitor how much toxin is being produced, what toxins are being produced, and what the entire microbial community is doing, we can create a forecasting model that can effectively prevent toxic events by knowing where they're going to be and how toxic they're going to be before they get there. Additionally, this is technology that EQO, us, we've already commercialized this for things like invasive and endangered species. This is an add-on. Gary's technology has already been utilized in fecal tracing. And all the cool things we do with that, the samples that we're grabbing for harmful algal blooms, we can also probe for things like that as well at pretty much no extra cost. The expensive bit is getting the samples. So we have a mobile system to collect samples. We have programmable auto samplers for collecting samples at say a water treatment facility or where we know runoff is happening. And then all the magic happens in our GLP lab. And then it gets sent to Gary to look at the entire microbial community. This partnership, this project is already moving forward. NOAA has given us some rapid funds to do some of the early work on this. We've worked with Limnotech to collect these samples. We're members of the Cleveland Water Alliance. EQO has a strong working relationship with Los Angeles Department of Water Power, U.S. Coast Guard, and Navy Research Labs. And Sigler is the part of NOAA that approved those funds. And as you can see, this is something that Dr. Herrera at NOAA is very interested in, not just from the harmful algal bloom perspective, but figuring out the entire omics of the lake and what's going on. And that's what we can bring in addition to preventing negative impacts to health and local economies. That's really what this is about. These next two quotes are directly from a recent kind of needs paper put out by OSU. And what they want to know is specifically what we're providing here. Determination of whether blooms are toxic and where toxins are moving, and prediction capability for severity of blooms months ahead of time. That's my time. I'm happy to take any questions. Thank you so much for being here and for being part of this. I see Bob is raising his hand. Yes, Bob.
Yeah. So how do you lyse the cells and how do you preserve the RNA? RNA is quite labile and in natural waters wouldn't last very long.
Yes.
But you also, there's some messenger RNA. It comes from cells that spontaneously lyse, but you've got to lyse cells to really know what's really there. So those are my two questions.
Yeah, sure. I mean, again, we can get more in-depth technical, but I'll give you the quick version. So EQO's extraction methodology for collecting samples, usually when people are doing DNA work, they're looking at like between 100 mils and a liter, or maybe with the other samples, you're getting up to 10 liters. We typically do on the mobile unit between 100 and 500 liters. And on the sedentary unit, we do 2,000 liters. And now the reason why we can do this is one, the sample cartridges are quite a bit larger than your normal system would be. And the other thing is, what we found is that RNA and DNA preserve much better when they're associated with some kind of particulate matter, be that cellular structures or sediment, especially in any area where you have a lot of, say, silicate or any positively charged calcites, things like that, can bind up and preserve the nucleic acid a little bit better. Now, on the cell lysis and like what we do in the lab, that gets a bit complicated, but we do have a proprietary technique for extraction, removal of inhibitors, and all kinds of things like that when working with dirty samples. My first company out of college was working for a company called Ambion, which built themselves as the RNA company. So RNA has kind of been my wheelhouse for the last 15 years or so, mostly in cancer research. This is kind of bringing it to the environment is definitely a new and cool thing.
What's the cost per sample given the volumes that you're processing?
Oh, so they're concentrated. So the cost per sample, we do this on a subscription model. So on those auto samplers, it's up to 100 samples for $72K per year of sampling.
Okay, thanks.
Who is your target end user and how do you plan to share the data?
Sure. So this project is becoming, what's really interesting is the more data we have, the better and stronger the forecasting model becomes. So right now we're working with NOAA, University of Michigan, City of Toledo, City of Cleveland, and City of Detroit. We had a meeting with all the water treatment facilities there as well. We expect that for the first year, this is going to be primarily publicly funded through things like this and grants and things like NOAA and stuff like that to build the data set. On the back end, it's a subscription model that eventually the municipality takes up the cost for that. Like I mentioned before, we're doing this with Los Angeles Department of Water and Power currently for invasive species stuff, and we're launching a very similar to what we're proposing for Lake Erie in Austin, Texas as well. And that one's paid for by Lower Colorado River Authority. Eirik.
Yeah, John, excellent presentation. What are some of the challenges that you see in terms of scaling this technology? What's the biggest challenge? And don't say money.
No, it's not money. The biggest challenge is kind of the same things that anybody working in water or infrastructure has, and it's just adoption of new technology, and then kind of the ability to not just collect data from multiple sources, but bring them together and bringing stakeholders together. That's kind of the biggest business kind of challenge we come into constantly is, permitting takes forever. These are usually how we go into this is as a sales channel partner. So we go in through a engineering firm for most of our contracts that already has a contract with the municipality, and then we become a sub-awardee. And that's really helpful from a business perspective of kind of making things move a little bit quicker because we're a small company and we're a startup. So getting any kind of RFPs and things like that for something that's so niche, it's not going to happen. We have to go in with a channel partner like an engineering firm.
Thank you.
Judges, we have time for one more question. All right, well, if there are no more questions, we will transition to the next team. And after giving the judges 2 minutes to fill out their rubric, but Mark, take it away.
Thank you, everybody.
You're very welcome. Thank you for the presentation, RNA Power. And as we're waiting for a couple of minutes, our next presenters will be curbing sediment. But before we do that, keep in mind these teams are vying for $45,000, trying to get to the next round, the final round, which will be in 2 weeks, November the 18th. And they're vying for $45,000, and that will be hosted. The finals will be hosted by the Cleveland Water Alliance on November 18th. $45,000 in funding and support services. This is why programs like this is very, very important, is to give these businesses a chance to demonstrate what they can do in a pitch environment. And clearly, we have an outstanding group of judges to help make that final decision. And these teams have put in a lot of time and effort to really come to this point today, and across 5 different cities representing the Great Lakes region and beyond. And we know the water that we have here in the Great Lakes, incredible. But we also know there are a lot of water challenges. We know that cities in this region have certainly experienced it, and we certainly experienced it here in Detroit this past summer with some of the challenges here in the Detroit area. So I want to say kudos up until this point to all the teams presenting. I know you're taking a collective deep breath, as well as you should. We have more presenters. And before I introduce our next guest, thank you to the Buffalo Bills fan who invited me to come for some Buffalo hot wings since my Detroit Lions are struggling. All right. Thank you very much. And continue to drop your comments as part of the chat room. Next, we'd like to welcome Curbing Sediment. And as they take over the screen, make sure that you unmic yourselves and turn your cameras on. And when you're ready, Felicia will start the clock. Make sure you share your screens. Thank you.
There we go. Sorry, it wouldn't let me see the unmute bar.
Fine. You're fine.
All right. You can hear me and everything?
Yes, we can hear you just fine. Go right ahead.
Okay. Good afternoon. We are Curbing Sediment, Connect to Protect. Sorry, it's not advancing. I am Helena Steiner, along with Ryan Winston. We will be presenting on behalf of our interdisciplinary team, which includes landscape architects, PhD students, and civil engineers. Curbing Sediment asks, how can we improve the function of a standard curb, gutter, and apron on a regular city street? Defined by a 6-inch grade change, you may ask, why does a curb need to be improved? Our streets are full of pollutants called first flush toxins. First flush toxins and sediment accumulate on the road and during storm events are carried with stormwater into the storm drain. Stormwater runoff transports pollutants, including sediment, nutrients from lawn fertilizers, bacteria, pesticides, metal, and petroleum byproducts to Lake Erie, impacting our biggest regional asset. Once in the water, similar to microplastics, they are nearly impossible to remove. Pollutants are ingested by fish, clogging their gills. Pollutants also bioaccumulate within aquatic life and impact terrestrial animals and humans who consume these organisms. The US EPA notes that 1/3 of public water systems in the United States were in violation of federal drinking water quality standards in 2016. We may say, but we have bioswales and green infrastructure to help clean our water. This is true, but the EPA cites construction activities, bare soil, erosion, and winter sand application as common sources of sediment in urban runoff, which, when routed to bioswales by stormwater, builds up at inlets, clogs soils, and smothers plants. Bioswales also have physical limitations, such as existing mature trees or narrow sidewalks, limiting their application in certain areas. Furthermore, sediment can clog catch basins, which can cause localized flooding. A typical curb and gutter is designed for the conveyance of stormwater only, and it does not provide any water quality benefit. Can we challenge conventional design standards like the curb to do more? With widespread use of curbs, small-scale changes have the ability to have regional impacts. If we can design a better curb, one that collects pollutants before they enter Lake Erie, we can improve the health of our watersheds. Regular maintenance of new curb, gutter, and apron designs can be performed by street cleaning machines already in use, or new maintenance practices coupled with green jobs programs can be developed. We've tested 21 alternatives to standard curb and apron via an iterative design process.
This video shows one of our lab tests from a top view. Simulated stormwater enters the mock road from the right with the curb and apron at the bottom. You'll note the roughness in both the curb and apron, with sediment trapped in the patterns as the simulated rainfall event continues. These lab scale simulations proved very promising for trapping sediment. Our lab test simulated a typical storm event in Ohio. Here you can see the sediment collected after many rounds of testing. Other pollutants like nutrients and metals attached to sediment, resulting in broader water quality benefits. On the left, you can see the performance of the roughness patterns that we tested in the laboratory. We note that the greater the roughness, the better the performance. The best performing designs were able to remove greater than 80% of the sediment and stormwater, and were able to do so for up to a month of simulated rainfall. These new designs can be used in concert with green infrastructure to reduce clogging or independently to reduce pollutants from roadways. Curbing sediment's small footprint can be advantageous in areas with mature trees and narrow sidewalks. Custom patterns can be developed for business improvement districts or by municipalities to adapt to specific aesthetic, hydrologic, and/or other physical conditions. Curbing sediment is a feasible alternative to the standard curb and apron design. By upgrading the curb, this new design has the power to transform the standard urban drainage infrastructure. We need step change retrofits to existing infrastructure to make big impacts in Lake Erie's health. Given how ubiquitous roads are in urban areas within the Lake Erie Basin, this solution, applied at scale, could have massive impacts on the health of aquatic ecosystems. Roads crisscross the landscape, forming an ever-expanding network of asphalt. According to the Federal Highway Administration, this network comprises over 4 million miles of roads in the United States. They are critical to facilitating movement of people and goods within cities. However, this network also acts as a magnet and superhighway for pollutants. Laboratory results suggest that modified curbs can collect pollutants from roadways. Small scale changes in design standards can have regional and national impacts. And with that, we will conclude and we'll thank you for the sediment, and we'll take you any questions that you might have.
I have a question. Can you, as far as the fabrication of the curbs themselves, can you talk about whether or not you can modify existing curb structures, or would this be through the manufacturing of new curbs?
Great question, Michael. I think there's options to do both. So for instance, think about rumble strips on the side of an existing interstate highway. Those are often ground into the asphalt using a sort of a drum grinder, if you will. And so I suppose there would be ways to do similar things to a concrete curb and gutter system. Some other things that Helena and I have thought about include casting in place a standard curb and gutter, and then using essentially a press in order to press in whatever indentations you desire into these facilities. Another option, a third option, would be to cast these at a facility, basically precast the curb and gutter, and then bring those out to the site and install them precast with the patterns already installed. Valencia, I see you have a question.
Yes. So really quickly, what is the cost over traditional curb and gutter? And then in, the typical 90th percentile event, okay, yep, in terrain, great. What about these massive storms we've all been experiencing? Does that precipitate additional street flooding versus just having the ability to go directly to the catch basin?
Really good questions. So yes, our testing so far has been at the lab scale. So we want to make that point. We have not done any of this in the field yet. That's one of the things we're really hoping to scale towards, one of the reasons why we try to join this competition. We did test just the 90th percentile storm, so roughly a 1-inch event in the laboratory. Certainly we are regionally getting much larger events with climate change. I think in terms of spread of water out into the road, this additional roughness during very, very large events is going to be a relatively minor impact. It may have a small impact, but I think that would be relatively minor. In terms of cost, again, we haven't built this at field scale yet, but I would suggest that once you get a mold made or some way to construct this at scale, we're kind of thinking this would be a less than 10% increase in total cost to construct the curb and gutter.
And then one other question. Typically, lake pollution is primarily driven by agricultural runoff. And so from a percent basis, what percent of the toxins are coming from urban runoff versus agricultural?
Yeah, really good question. So certainly for nutrients, that's absolutely true, right? 85% plus are in the Western Lake Erie Basin are agriculturally related. I think when you look at sediment in urban runoff, it's probably a much higher percentage that's coming from urban areas. I would be making an educated guess here, but I would guess maybe 25% of the sediment, it might be coming from our urbanized areas. And a lot of that, a large fraction, is going to be from the impervious surfaces for sure, including roads.
Thank you.
Bob? Thank you. Bob?
Yeah, the crevices are going to create opportunities for freeze-thaw cycles to increase the rate of degradation. Have you made any estimates of what that increased cost will be? Because I think your greatest barrier to adoption is going to be cost.
Yeah, so certainly freeze-thaw cycles are an issue across the Great Lakes region. These indentations will fill with sediments. That's one thing that Helena mentioned. You absolutely will have to street sweep or do some type of maintenance like that. In terms of the freeze-thaw cycle, it was not something that we simulated in the lab, so we don't have any direct data to support that. But there are other as I mentioned, the rumble strips along the side of the highway, there are other common uses of this type of technique on other road types of roads. So, you know, if they're only a 1/4 inch deep or such, which is what we simulated, we think it's a relatively minor impact.
So real quick, lots of cities don't street sweep any longer. So have you looked at what, you know, how often would the street sweeping have to happen to keep these effective?
Yeah, so we simulated up to a month of rainfall events in the laboratory, and we were still seeing substantial sediment removal from these repeated 1-inch events that we were running back to back to back. So, you know, on the order of every 1 to 3 months, I would guess, quarterly in that range would be what I would suspect at field scale.
Hey, Ryan, I appreciate the in-house validation and simulations that you guys carried out. Have you had conversations to try to validate this idea with municipalities, and what's the feedback that you received? Just curious, and construction firms as well.
Yeah, absolutely. So I might let Helena talk about the construction firms. I would say we've approached City of Columbus, Ohio Department of Transportation, and also our campus on-campus facilities staff. And I think we are making some headways with trying to do this at field scale on campus at OSU in Columbus. Some of the feedback, we actually tried for a grant with Ohio DOT and missed out by 1 spot. So we've actually, I think, gotten some good traction. And I think there might be a possibility to get some funding through Ohio DOT in the future.
We haven't really spoken to any designer construction firms specifically. I do have a design background in working at landscape architecture firms and working on green infrastructure projects that were pilots. So I think that we're willing to partner with anyone and everyone to try and figure out how we can answer a lot of these questions, because we have a proof of concept. We know that it can work at the lab, and we'd love to see it deployed at a larger scale and study it in place. And we're very flexible with how we might adapt the design to meet the needs of the city or the weather that may happen.
I'll just, one comment as somebody who comes from a background of waste management, even if people aren't street sweeping, I love the green jobs angle. It takes more effort to divert material from landfills, what I always say. So I'm not turned off by that at all. But just, have you put any thought into the actual materials you're going to use for this? Because I think it's safe to say that concrete isn't the most environmentally friendly material. And is there something alternative to that you can use for this process? Or do you plan to just use what's already being used in curbs?
I think initially we'd probably just stay with concrete, just because it's something that we're already asking people to reimagine the curb and potentially add kind of new maintenance regimes to it. So we know that it could be built out of concrete. We've had loose discussions in our team about other materials that may happen at OSU's campus. For example, we have stone curbs, so we don't actually have concrete curbs on a lot of the campus. So if it were able to be manufactured offsite, I think that would also allow for greater flexibility of materials. We also, there are some new types of concretes that are emerging that have kind of more biological potential as well, so I think that the concrete problem is a big problem, and there's a lot of people looking at it, and I hope that maybe there's some solutions that can come in the near term for that.
Thank you. That's all the time we have for questions. I'll give the judges a few minutes to fill out their rubric. If they could mute their mics, turn off their cameras, and I'll let Mark introduce the next team.
As they're filling up the rubrics, again, we want to give a special thanks to the following cities of Cleveland, Toledo, Buffalo, Windsor, Ontario, Detroit, representation from the Great Lakes region. Excuse me, doing a great job making their business cases, making the cases. It's important that we continue this conversation. Great question about the flooding situation. We know that parts of this country, including the Great Lakes region, was hit hard this past summer with the flooding and all the water. So wonderful presentations. We want to thank all of you for participating. Great questions by the judges. And it's important that they continue to stay engaged. They are staying engaged. And as we begin to introduce our next group of presenters, as we come out of this one, Felicia will be taking us into break and letting us know specifically how much time that we have. And then after break, we'll have a couple more presentations, and then eventually we'll make the announcements a little bit later this afternoon. All right, with that, I'd like to again thank you to Curbing Sediment, and I'd like to introduce Algae Busters. And it's now your time to certainly unmute your mic, share your screen, turn your cameras on, and the clock will start when you're ready to start your presentation. Good luck.
Thank you. Can everybody hear me?
We can hear you just fine, yes.
Thank you. And I am going to get our presentation going here. It's coming up. Do you see it?
Nothing yet. Here we have your screen view.
All right, hold on. There we go. And hold on a second. I'm going to do one quick thing. I don't know why I'm having an issue here. All right, one quick. There we go. Can everybody see that?
I want to defer to Felicia.
Yes, we can see it. Are you able to play from start?
Yes, I am on the, do you see a full screen?
No, we do not. It's if we're not able to, that is okay, and you can just do it with the non-full screen.
Okay, hold on. All right. Well, let me do one more thing here. Hold on. I'm gonna stop a share, and then I'm going to go back in. Share. Now, any better?
That's good.
Great. Okay. Well, good afternoon. We are Algae Busters, and we have a shocking innovation that will help improve surface water quality and the sustainability of farms. We are part of Neuendorfer Incorporated, a Northeast Ohio company that has 46 years experience in reducing air pollution from industrial sources. Our capabilities include consulting, design, build, and implementation. We're expanding into solving problems related to water pollution. What we are proposing is not a study, not a monitoring program, and not an idea to be tested in a lab. We are bringing a solution that was originally developed to reduce nutrient pollution in the Chesapeake Bay watershed over a decade ago. Phosphorus from runoff is a major driver of Lake Erie's harmful algae outbreaks that impact surface water quality in the western Lake Erie Basin. Spreading manure from lagoons is an important process for farming. It provides a beneficial reuse as it contains a lot of nutrients for the crops. Runoff from the storage systems and from land application infiltrates our waterways. Once the phosphorus gets into the water, it's kind of game over. Farmers are key partners in the solution, and we recognize that we have to be sensitive to their economic constraints. Our solution does not require the farmer to change their practices, own costly equipment, or plant something different. The western Lake Erie Basin covers nearly 7 million acres, and it encompasses Northwest Ohio and portions of Indiana and Michigan. In Ohio, 20% of the total applied phosphorus comes from manure application. The sheer number of farms that produce manure in the region is huge. To meet the challenge, we are going to apply a novel technology that uses electrical pulses to enhance the biological process that takes place in the existing manure lagoon. We're going to use something called pulsed electric fields, or PEF. PEF has been successfully used in industry, specifically with food preservation and juice extraction. It's also used to enhance the performance of anaerobic digesters. Unlike most PEF, our technology consumes 20 times less power. Results from previous field tests indicate we are treating at a cost of less than 0.2 cents per gallon. The process is simple to implement. A few weeks before spreading, our system arrives at the farm, and the manure is pumped through a series of treatment tubes. As the manure passes through the tubes, electrodes apply a pulse that rupture and open up the organic matter, which allows the phosphorus to settle to the bottom of the lagoon. The process continues until everything is treated. And after a settling period, the farmer can begin their normal process of spreading the liquids in the fields. Sorry, it keeps going ahead. This unique approach creates a affordable and reliable method to reduce nutrient runoff and to keep it from entering the watershed. Evidence also has shown that it puts nutrients in a form that allows the plants to absorb them better. This further reduces the occurrence of runoff and provides a benefit to the farmer. Now let's look at the numbers. Based on data from our previous applications, if we just targeted the hog and dairy farms, we could remove 11,000 tons of phosphorus annually from the manure liquid. That would equate to about $9 million in chemical fertilizer cost offset, and the cost to treat those lagoons would be about $3 million. I think I moved ahead. I'm sorry, keeps jumping ahead on me. Our next steps are critical in the process to implementing a full-scale solution. We want to deploy a full-scale pilot. We are currently investing our own resources to build a full-scale treatment system and will be ready to deploy this spring. If we are successful in this competition, the funds will help offset operating expenses and testing. Field testing is important as it helps us understand more of the impacts and validating results. If the cost to do this was zero, it would be possible that nobody would do anything. It will take stakeholder collaboration to get the solutions to the table and create incentives to get farmers to adopt the solutions. Ohio EPA's H2 Ohio program is an example of that, and we are proud to be one of the 10 technologies selected that they're reviewing this year. Moving forward, we want to get this simple and scalable solution into action and start attacking the problem at the source. We're ready to start and look forward to be part of that solution. I'd like to open this up to the panel now, and thank you. Go ahead, Bob.
With that presentation, I would benefit from more explanation of how this works, because normally, if you break down the organic matter, you're going to solubilize the phosphorus rather than converting it to a solid form that might settle out. And so I think I may not fully understand how this is working, or maybe that's your purpose, is to increase the solubility so more of it is absorbed by the crops. That's the part that I would benefit by a little more explanation.
I think it's maybe a little bit of a both and. You know, some of it you can get it to go to the bottom of the lagoon, and eventually, you know, at some point in time, the farmer is going to pump out that lagoon and put that sludge somewhere, and that's a beneficial resource. But we're also liberating that phosphorus from the organic and inorganic materials, making it more available for the plant. You know, the plant doesn't strip the phosphorus; it has to be there for it to take. So we're kind of mineralizing the phosphorus before it gets to the field.
Okay, thanks.
Steve, great presentation. Really interesting. Can you tell us just a little bit about your team? I see your team's there, sort of your background and expertise in this area.
I'm president and owner of Neuendorfer Incorporated and been involved in the business for 36 years. Karen, my wife, is CFO and also owner of the business. Jeremy Timmons is our VP of engineering, and he's a dairy farmer. And Tony Frick is our senior mechanical design engineer, and Becky Rice is our grant specialist. So she helps us get involved with programs like this.
Do you have data that shows the percentage of phosphorus present in the manure that ends up as precipitate and the percentage that ends up as soluble plant available phosphorus?
That's one of the things I think we got to narrow down more, and part of our testing would include that. We know that from previous testing, we've been able to get 80 to 90% of that phosphorus in that supernatant layer down to the bottom.
Okay.
And real quick, these units, would they be mobilely deployed, or once a farmer has it, he has it?
Good question. And I had this in my appendix here. They're mobile. And because you're only going to do this 2 or 3 times a year, depending on the cycle. So these are examples of the previous mobile units that we've used. We're building a more enhanced version of it now. The one on the left actually treated sludge that was going to be applied to farmland out in Western Ohio. And the one on the right is a mobile unit that was used to enhance the anaerobic digester, which is to the left of the unit. So we can pull these things with pickup trucks. I mean, it's fairly easy. And as you can see, they have their own onboard generator. So, it's kind of a set it and forget it.
We have time for one more question.
I mean, you kind of answered the question I was going to ask, but you're saying that your PEF unit is significantly cheaper than others available in the market. Are you just using it for this application, or are you using it for digesters already?
We are using it on digesters and hope to expand in that market more. We've shown that in the bioenergy world, we are looking at increasing biogas production by almost 20% by going through this process. And also has other beneficial applications there. It is also being used in plant extraction as specifically around CBD oil. It can replace the ethanol that's used in the extraction process.
Thank you.
Welcome.
Thank you, Algae Busters. Okay, so next up, we will have a 6-minute break. We will be back at 4:29 to queue up the next team. If everyone could turn off their cameras and mute their mics and take their break.
I live inside my own world of make-believe. Kids screaming in the cradle.
I just can't let you go. Lord knows that I've tried to. You said I was the only one. No one likes being lied to. You made this mess and left me with the pieces. Now I wanna burn all the bridges between us. I can't focus, I can't forget. I've been thinking too much lately. I just need to clear my head. I just need to clear my head. I've been stuck on your memory, but it's not like I need it. And you may have some history, but we don't have to repeat it. You made this mess and left me with the pieces. Now I'm gonna burn all the bridges between us.
I used to be the lost boy running insane. I used to be the ghost boy looking for fame. I used to work so hard to get it, so hard to get it. I used to be the one living in the fast lane. I used to be the one who only cried in the rain. I used to work so hard to get it, and so hard to get it. And so hard to get it. I used to be the lost boy running insane. I used to be the ghost boy looking for fame. I used to work so hard to get it, so hard to get it. I used to be the one living in the fast lane. I used to be the one who only cried in the rain. I used to work so hard to get it, and so hard to get it. I used to be the lost boy running insane. Used to be the ghost boy looking for fame. I used to work.
Welcome back, and we're back for the final, excuse me, the final two presentations. We've had 10 thus far, only 2 remaining, and then the judges will begin their deliberations. So I'd like to take this opportunity now to invite Let's Float Some Sensors on the Lake up to the stage, if you will. Share your screen. It looks like you're already beginning to share your screen. Unmute yourselves, and you can take over the presentation. Once you begin, you have 5 minutes for your entire presentation before Q&A. All yours.
Is my mic on?
Yes, it is.
Okay, great. Let me start my timer. All right. So, well, first off, hi, all of my Lake Erie neighbors.
Hi,
Glad to be
George.
here.
Do you mind turning on your camera?
Oh, okay. I'm sorry. Let me see. I'll have to unshare here. Yeah, sorry about that. Camera. Start. Oh, there I am. Okay, now I share. Sorry about that. I thought I had it all figured out. There's some detail. How's that? Are we good?
Yeah, all good.
Okay, good. So, hello again. So we're Team Remote Floating Sensor, or Let's Float Some Sensors on the Lake. And this project has evolved a little bit. I originally envisioned a floating sensor, drifting sensor with cellular connectivity, with sensors, GPS, all of that. You know, released in Detroit, and then I thought, oh, it's going to be a challenge to send a boat out to get these. So then I decided to make it light enough that it can be retrieved by drone. And then I ended up talking to some people, the mentors, and they said this drone idea is a good one and could be used for the fixed sensor or the fixed buoys we have. So I started moving forward with that and came up with a strategy to make a very lightweight buoy with a heavy lift drone transport. And the benefits here are manifold. The buoys need to be, the sensors need to be maintained about once a month. So this will make that easier and cheaper. And it will also extend the season, and because the boats have seasonal limitations, and perhaps we'll be able to be over the entire lake depending on drone range. So I looked into the heavy lift drones, and there's a company that has drones that will carry this for, you know, great distances. I need more details. So I'm going to go through these quickly just to show the weight. We have an enclosure, the tether and anchor, the electronics and the sensor. The platform and the tether and anchor aren't part of the weight that matters. So this is what the drone looks like, although the solar cells are out now, because I did determine that with batteries, which are lighter, I could run for over 2 months, probably close to 3. It's nice that electronic specifications are detailed. Like I said, this is a proposed enclosure. Now the platform and tether and anchor we need to replace in the lake, and just put a platform there that could receive the drill or the buoy itself. So there'll be a locking mechanism. So that would stay in the water so that it stays stationary, but wouldn't be part of the weight that needed to be carried. And I'll just go through some of the weights here just to show that I've covered it all. And this is the electronics and sensors. So it comes in, there's the probe. It comes in at about 6 kilograms. My original goal was 10 kilograms. So it's well within, what my plan was, even lighter. And as far as range goes, I'm still waiting for specifics from the drone companies to determine how far we can go with it. So the future plans on this, being just an individual who's concerned about the lake, I plan to open source everything, hardware, software, physical design, all documentation. So this could be repeated anywhere on the other Great Lakes and any waterway across the world. And it's a variable platform as far as the sensors go, the idea of drone. And I plan to work with locally the UB University of Buffalo Sustainability Program, Blackstone Launchpad, and even if it's open source, it's a viable thing to launch a startup. You could sell the hardware and keep it, still make profit. You can sell it at a profit. And the other thing is the materials. We still need to determine the manufacturing aspects of it, but the honeycomb material, the composite honeycomb material, can be worked with like wood, just with a tungsten carbide saw blade. So the foundry in Buffalo is a nice innovation hub that has a wood shop, so they might get involved, like getting the Blackstone Launchpad and Sustainability Program to work with the foundry might be a really good combination. And, I kept it under 5. I'm ready for questions. Thanks.
All right, judges, if you can unmute your mics, turn on your cameras and ask your questions.
Sure. Sorry, can you just provide clarification on what you're sensing?
Oh, let me pull my slide back up here. Yeah, that was a list there. How do I share screen? I go to where it says share screen and I share it. Yeah, this is largely what is currently being done in the drones. There's already an infrastructure of buoys out there, and the idea would be to either add to it or replace them for the cost reduction. Apparently, the sending a boat out to get these monthly is quite expensive, and this would provide that. But so, oxygen reduction potential, dissolved solids, dissolved oxygen temperature, you see it there. And I do have a cost model for it. The cost of materials for the buoy itself comes in somewhere in the 2,000 to 2,500, depending on manufacturing costs. But again, it's going to be easy to manufacture, and the quantity isn't high enough that it could be done, by a small group. But oh, go ahead.
Oh, and the data will be collected when the drone picks up the sensor, and then it will be replaced.
Oh, I'm sorry, I didn't make that clear. The data, it's got a cellular modem. It will have a cellular modem on it. So it's continuous data, probably once an hour or something like that in order to save power so the battery will last. But yeah, no, the reason for the drone is that it needs to be retrieved to recalibrate the sensors. So that ends up being a costly thing that happens, over the season. Yeah, the data, that can fit into the infrastructure that's already there for dashboards who have, the people who are doing that. That's not my expertise, but I can provide the data so that it can be used for whatever, for, the infrastructure that's there. Yeah, it's largely improvement to current infrastructure rather than something really new.
Yep, the real innovation is the use of drones to transport the sensors rather than the use of a boat. So have you done a thorough cost estimate it sounds like you haven't yet been able to determine with certainty what the costs for the drones will be because you don't know the range yet. But if you make a reasonable estimate of that based on existing drone technology, and if you have an estimate of what the cost is for retrieval using boats, and can you make that comparison and determine what the cost savings would be for use of drones rather than use of boats to retrieve the devices?
Unfortunately, I haven't been able to do that yet. I've contacted that drone company, Griff, and they haven't gotten back to me. I'm going to have to press harder on it to see what either the drone, it could either be that people deploying the buoys buy a drone and get somebody to do it, or they hire them as a service. And that cost I don't know, so I can't really compare yet. I'm going to push hard before, if I go to the finals. And I'll probably do this anyway, even if I don't go to the finals or win, because I can just get it started and I think it'll happen. But yeah, that is on my mind. It's just I haven't been able to yet.
Yeah, George, this is Mike. I just to follow up to Bob's question, I was looking for that cost benefit analysis, but if we're still collecting the cost side of things, it's hard to understand what the benefit is yet, unless you've estimated that overall.
I don't know I think the heavy lift drones are rather expensive. So part of that will be the balance between buying a drone and having someone do it versus what they might charge as a service for that.
Right.
And once I get through to them, I did send them an email, and I think it's time to ring their phone a lot so they pay attention to me. And perhaps that drone company that presented earlier has some technology that would be useful. But yeah, I'm hoping, if I go to the finals, I'm hoping to have that information by next week.
We have time for one more question. Well, awesome. If there are no more questions, thank you. Let's float some sensors on the lake. I'll give the judges 2 minutes to fill out their rubric, and then I'll let Mark introduce the next team.
Thank you. Thank you, Felicia. I appreciate it. Again, I want to give a special thank you to today's host, TechTown Detroit, for hosting today's event, the Erie Hacking. We appreciate that continued support. They're doing great things, as they've always done for several years here in Detroit. And I've been fortunate to be engaged with TechTown probably for, I think, since 2008 or 2009, a long time. Wonderful organization. And again, these organizations, these groups today are competing for $45,000 in funding and support. And the finals will be held in 2 weeks, the 18th, and will be hosted by the Cleveland Water Alliance. So exciting times. I hope, I know we got one presentation left. That's it. Then the judges are going to deliberate, and we'll certainly be making the announcement of those of the finalists. The finalists going to Cleveland or to the next round. So thank you all for your support so far. And thank you for let's float some sensors on the lake for your presentation. And last but not least, pay attention to Agri-Tech Ohio. And when you're ready, please share your screen, turn on your mics. And once you start, the clock will start through Felicia. Thank you very much.
Can you hear me?
Yes, we can. Yes.
Okay. I'm trying to get it into.
So if you click on the tab slideshow.
Which one?
The tab slideshow.
Chat?
The tab. So it goes File, Home, Insert, Design, Transitions, Animations, and then Slideshow on the top.
So there we go. That worked.
And then you can click, yeah, from beginning.
Okay, ready to go.
Whenever you are.
Using our patented CRBBP process, we plant and then we multitask very special biocrops to cost effectively protect Lake Erie and all the cities that are on its boundaries by removing excess nutrients and other contaminants from watershed soils, capturing lots of CO2 to combat climate change, and then making circular economy bioproducts from the biomass and in some cases from waste plastic that we can add to our filler powder. Hi, I'm Joe James. I'm a former 33-year economic development professional. I served a 6-year term as a secretarial appointee on the Federal Biomass Research and Development Technical Advisory Committee. I invented and I patented our CRBBP process, and I've licensed and patented a biomass carbonization process. We're focused on several local, national, and global challenges. The lake is suffering from harmful algal blooms, and to protect the lake, we can remove excess nitrogen and phosphorus and other contaminants from watersheds and even from the lake. We're also focused on climate change, which impacts the lake and the world. And we have a very effective, cost-effective CO2 capture, as well as carbon reuse and sequestration mechanism. And we're focused on other environmental challenges impacting air, soil, and water. Our solution is our patented combined remediation, biomass, and bioproduct production process. I think you understand why I call it CRBBP without having to say all those words. And I've just described to you what it does. It does what it does because of crops like our favorite crop, biomass sorghum, which grows fast and big in 6 months and captures lots of CO2 per acre. On the left, you see a field of standard sorghum at its 6-month maturity. On the right is our biomass sorghum, also at its 6-month maturity. You can see the differential in the amount of crop material per acre. We asked the University of California at Berkeley to do an analysis on the CO2 uptake capability of biomass sorghum, and our crop captures almost 4 times as much as an equal acreage of trees and twice as much almost as switchgrass. So we can extract lots of nitrogen and phosphorus from watershed farm soil simply because our crops grow so big so quickly. And if we wanted to treat contaminated wastewater or water or runoff, that water could be sprayed into fields where our crops are grown so that they could also be, the contaminants and the nutrients could be removed. And if there was a need to treat surface waters, we could actually create a floating farm blanket, if you will, that could also treat the water, but also keep it cooler in the summer months if there was a problem with too much heat, which I understand occasionally happens in certain parts of the lake. After our crops have done their environmental services, we harvest them and we take the resulting material or biomass and we convert that into circular economy bioproducts, which never have to end up as waste. So we can make a superior alternative to carbon black filler powder. You may know that that powder has all kinds of nasty stuff in it because it's essentially made from purposefully underburning oil and creating soot. But it's used to make plastics, composites, and tires are 30% carbon black. We can also make a superior poultry house bedding that's more absorbent and treats ammonia better. And then we can harvest the litter and convert that into a nutrient-rich biochar soil amendment. And there's an Ohio company who's had an interest in that to include it in their potting soil. In addition, we can use our filler powder and blend it with waste plastics to create new products. Here is a pallet, a shipping pallet made from our filler powder and waste plastic. Our competitive edge is our multitasking feature, which means we do a lot of things with our crops we're able to share the cost of growing them over all of the activities, including the environmental services, as well as making bioproducts. We have some outstanding collaborators and R&D partners, the Exelon Foundation of Dominion Energy, the Electric Power Research Institute, the U.S. government, a number of universities, including the University of Akron, who we're collaborating with to make our bioplastics. We've accomplished several milestones, including demonstrating our ability to extract nitrogen and phosphorus from Chesapeake Bay watershed farm soils. We've demonstrated the efficacy of our bioproducts. Our operating fillet in Maryland was selected by the Exelon Foundation's Climate Change Investment Initiative, and our Virginia operating affiliate was invited to be part of the Dominion Energy Innovation Center. And Dominion has operations in Ohio, and we're having discussions with them about planting our crops in some of their operations in Ohio. We certainly have competitors. Our advantage over them is that our costs are much lower, and we're able to do a lot of different things, and we make bioproducts at the end. So again, using our patented CRBVP
Thank you. That's the 5-minute mark, and I will have to call time now.
Perfect. Thank you.
Bob?
Wow, this is very impressive. But at the heart of it is cost. And you did mention that cost is your advantage over your competitors. Can you tell us a little more about that? And is the cost of the products you produce low enough that that this is financially viable? Ultimately, that's the key.
The answer, the summary answer is yes. In fact, this process was invented because we were originally making something called bio coal, and it cost 2 to 3 times as much as regular coal. And we were counting on Obama's Clean Power Plan to encourage and incentivize utilities to co-fire that fuel. When that plan didn't come through, we had to figure out another way to use the carbonization process that we have. So, for example, our biochar may cost us about $200 a ton to make, and the market for it's around $300 a ton. Our filler powder may cost us around $300 a ton to make, but the market for that is about $400 to $600 a ton. So we are very effective in terms of not only the bioproducts, but our cost of treating land. We're actually creating a cash crop as we grow our crops in farmland to pull out nitrogen and phosphorus. So that adds to the cost effectiveness of what we do.
Thank you.
I just have a couple of questions because this is a lot. It's all exciting, and I'm glad to see that you have so many different uses for everything that you're creating. Can you just reiterate what you're using the actual crop you're growing for? Number one, and then number two, what is your growth plan from here? Because it's clear that you've demonstrated that it works.
I didn't quite understand your question. Can you say that again, please?
Just you're growing the crop, right? Like, what is the actual crop? Are you turning that into something?
Yes, we grow these crops, and as they grow through their roots, they're going to pull up the excess nitrogen and phosphorus, and in case of contaminated soil, also some of the contaminants that are in that soil. They go from 0 to about 15 to 20 feet in their 6-month life, their annual crops. We then harvest them after they performed environmental services that I've just described, and we grind them up, and we may carbonize that material and turn it into a filler powder. If you're making a tire is black because it's been blended, rubber's been blended with something called carbon black filler powder. We make a bio-based alternative to that that doesn't have all the nasty stuff, the contaminants in it that are really dangerous for health, but still makes a very good powder that holds the rubber or the plastic together. And we're doing that in collaboration with the University of Akron School of Polymer Science.
Okay, and yeah, sorry, there's just a lot of things, so I missed exactly what that stage was. But what is your growth strategy or plan? Is it Great Lakes region? Is it waterways? Is it? I just would like to hear more.
Yeah, our strategy has been to partner with utilities, electric utilities, because they have a dramatic need to reduce their carbon footprint. So I mentioned the Exelon Corporation. That's the nation's largest utility, and we're collaborating with them in their operations in Baltimore City in Maryland. And we're also partnering, we just started partnering with Dominion Energy. And as you might know, Dominion has operations in Ohio, and we're in negotiations with them to plant our crops there. But we're also working with other groups that are involved in rural Ohio and assisting farmers. And so we intend to collaborate with farmers and help them rotate our crops through their fields, particularly those fields that have high nitrogen and high phosphorus, in order for our crops to do a much better job than regular crops would do in removing those nutrients and keeping them out of the water system.
Hey, Joe, just two quick questions for you. Excellent presentation. One is, can you just provide us a little comparison how sorghum compares to other biomass crops when it comes to inputs, things like fertilizer, water usage, and whatnot? And then can you also, can you also tell us what's the immediate next steps and for this initiative, this project, and how could this funding benefit that?
Well, first of all, biomass sorghum is just much bigger than these other crops. It grows much more rapidly. So it's going to be twice as high as corn, and it will uptake twice as much nutrients or near that as corn would. It doesn't require any substantial additional fertilizer or water or anything else. It's just it was bred, and you saw the earlier picture of standard sorghum. This crop, biomass sorghum, was bred as a crop to make lots of material per acre because they wanted to use it to make cellulosic ethanol. So it's sort of like a racehorse, and it just races forward and grows very quickly, and it's sucking up the nitrogen, phosphorus, and other contaminants that are in the soil to do so. I might have missed the second part of your question. What was that?
Just what are your immediate next steps for this project, and how could this prize help you?
Well, we intend to be planting our crops this spring, both in the western part of Ohio, in the watershed of Lake Erie, where there's lots of farmland, as you may know, that has high levels of phosphorus and nitrogen in it. We also are planning to collaborate with our partner, Dominion Energy, who has operations related to gas distribution in Ohio. And we're discussing with them planting our crops in their sites, capturing lots of CO2, which is part of their effort of reducing their carbon footprint, and then converting the plant material into a biochar and burying or putting that biochar in the soils of their sites. And we may repeat that several times over as a way of capturing CO2 and sequestering it in the form of biochar in the soil. And we're working with Dominion to try to qualify that activity for carbon credits.
All right, thank you, Joe, and thank you, judges. We are now going to transition to the judges' deliberation. So go ahead and turn off your mic and turn off your camera. And I will let Mark take it away from here.
Thank you, Felicia. Thank you to all 12 teams. You've done it. You've presented. Take a deep breath. Take a deep breath. Thank you again for all of your hard work, your pitches today. The judges are now deliberating. Every one of these projects is exciting, beneficial to the community, to this particular region. We will now be breaking while the judges deliberate, and we will reconvene at 5:30 for the announcement of the winners. We'll reconvene at 5:30 for the announcement of the winners, so hang tight. Make sure, we'll make periodic announcements for you to come back. But thank you all for your participation. Thank you for being here this afternoon. We've enjoyed it thus far, but don't go anywhere. Stay tuned and find out who the finalists are going to the next round of November 14th. We'll talk to you soon.
I've been talking in my sleep, been running deep.
Okay, I will.
Everyone, just FYI, the judges are deliberating. I just dropped in on them to see how they're doing, and they're into the conversations very deeply right now. So they are deliberating. We thank you very much for your patience. Again, I want to make sure to acknowledge, you see the judges on the screen. We want to acknowledge all the participants, of course. We want to acknowledge the representation from the 5 cities, including Detroit, Cleveland, Toledo, Buffalo, New York, and Windsor, Ontario, for certainly providing these teams to make their pitches today. And we just want to continue to acknowledge the hard work and time. It's never easy to give a presentation, let alone face-to-face, and of course, not over Zoom. And of course, once you make that presentation, you can take you can take that deep breath, right? Take that deep breath and just waiting to exhale, and then you exhale. So just hang tight for a few more minutes, and we'll be back to make the announcement for the winners, moving on to the next round. Which will be November 18th. Will be hosted by the Cleveland Water Alliance on November 18th, with an opportunity to compete for $45,000 in funding and support services. And today we want to thank TechTown Detroit for hosting the semi-finalist pitch competitions today. We'll be back shortly. Hang tight. Don't go anywhere. Everyone, in 5 minutes, 5:30 Eastern time, we'll be making the announcement and announcing those who will be proceeding to the next round. So hang tight. We're getting here. You feel the excitement building. The judges are wrapping up, and we'll be back with you shortly to make the announcement. Thank you. And the drama is building. Less than 2 minutes, we're going to announce those who'll be advancing to the finals. It's getting close. Boy, can you just feel it? You can feel it. You can feel it. You can feel it. You can feel the tension, the excitement in the air. A lot of great excitement. Again, we want to thank everyone for participating. We sat through 12 presentations today, 12 semifinalists who are all to be applauded for the hard work and dedication and trying to make this region better, trying to address the water issues that we all have, that we're all facing. We're from different parts of this region, but we all have similar challenges. Ohio, New York, Michigan, Canada. So just hang tight. In less than a minute, we are going to be announcing the finalists. All right. So just hang in there for a tad longer and we'll get started. And it's been my honor, by the way, to be the MC for today's event. And yes, it's been a wonderful event. My name is Mark S. Lee, and if you're ever in Detroit, check me out on radio or TV shows I contribute to. And I write a business blog for Crane's Detroit Business, amongst other things here in the Detroit area. All right. We're counting down. All right, here we are. Are you ready? Are you excited? You ready to do this? All right, here we go. All right, everyone. I hope you enjoyed your break and thank you for your patience. And before we make the announcements, however, I want to remind you that Erie Hack is about more than winners. This competition has cultivated and accelerated countless amazing ideas, forged lasting partnerships, and driven a conversation around the value of our regional water resources. Erie Hack has created a powerful innovation ecosystem throughout the Lake Erie Basin that promises ecological and economic advancement for all of our communities. And you should be proud of all that you have done so far and how far you have come. After today, some teams will advance to the finals on November 18th, and some will not. But Cleveland Water Alliance, TechTown, and a myriad of great partners across the region are dedicated to working with and providing feedback to every team from any stage of the competition that is interested in pushing their project into the future. All right, here we go. With that said, it's time to announce our Erie Hack 2021 finalists. The moment you've all been waiting for. The moment these teams have been working toward for months. Are you ready? I'm ready. Here we go. Okay. I'm excited to announce that 6 teams will be moving on to Erie Hack Finals, and those teams are, drum roll, 1, Agri-Tech Ohio, with their patented combined remediation, biomass, and bioproduct production process. Congratulations. Water Warriors, with their Poseidon pellets. RNA Power, with their harmful algae bloom forecasting model. Life Magnetics, with their innovative method to detect pathogens and production of toxins by algae in water samples. Blue Lion Labs, with their microfluidic sensor for the rapid analysis of cyanotoxins. And last but not least, and curbing Sediment, with their innovative curb redesign. Congratulations to you 6 teams that will be moving on to the finals. And congratulations. In addition to advancing to the finals, where they will have the opportunity to compete for $45,000 of funding and support services, each one of these 6 teams will take home $1,600 of prize dollars today. So each one will take home $1,600 of prize money today. Again, congratulations to our Erie Hack finalists and to all the teams who have made it this far for your hard work. And once again, thank you to all of our judges for volunteering your time to hear these compelling pitches. Felicia will be reaching out to all of you with the next steps and more information. We invite you all to tune in into the finals on November 18th, again, hosted by our friends at the Cleveland Water Alliance. I want to take this opportunity to thank you all for tuning in. Enjoy your evenings. And of course, me being from Detroit, and we may be 0-8, whatever our record is, as we always say here in the Motor City, go Lions. Have a good evening, everyone, and congratulations to all involved.